Okay, so while everyone is coming in, so this is going to be our introduction to version control, and we're going to be using Git and GitHub to do this. So before we get started, can I just have hands up, anyone who's used GitHub before? Hands up, thumbs up, some sort of reaction. A few? Yep. Okay, nice. So we've got a few people already used it. That's excellent. For those who haven't, we're going to need you to set up a GitHub account, which is free to do. It's a really good resource to have. So can I get you all to go to github.com? I will put the link in the chat for those who don't have it. So we need you all to go to that website and we need you to set up an account. When you set up your account, we want you to use an email that you're going to be comfortable using for the rest of your project. So it can be a personal email or it can be the email with which you applied for the Pawsey project. It's really up to you. I know that GitHub does have certain extended features for students, so it might be worth considering using your uni email address to set up, but as I say, totally up to you. Whatever email address you use, we're going to be using basically for the rest of this tutorial, and probably also for your projects. Okay, so people who are setting up accounts, when you've got one set up, can I get some sort of reaction, a thumbs up or a done in the chat or something, just so I know roughly how long it's going to take? Install the desktop application. So you don't necessarily need the desktop application. Kevin, are you on Windows? Can you remind me? You on Windows, Linux, Mac?
I'm using Ubuntu.
Ubuntu? Okay. So we can just use the command line interface. That's fine for this.
Okay. Cool. I'm just used to using the app on when I used to use Windows on my laptop, and it makes it easier than typing the commands into the terminal, in my experience.
Yeah, no, that's very fair. So spoilers for later, but we're going through all the commands with the terminal just to sort of show you how it works. But that is kind of the old school way to do Git. So at the end, we're going to show you how you can integrate it nicely with some text editors, but I will let David cover that a bit later on. So yeah, we are going to make your lives easier in the long term, but we want to start out with the command line.
Sounds good.
Awesome. So I haven't seen any reactions. Someone who was making an account, can I just get a thumbs up if you managed to successfully make one? Yes, awesome. Thank you, Lara. Okay, the other thing we need you to do is we want you to go back to the Google Sheet that you were on yesterday, which I will put in the Slack, where you selected Pawsey training accounts. Now we're going to need these Pawsey training accounts again today. So if you're here today, I just want you to put your name in bold next to the account that you were using yesterday, just so we know that it's still taken. If you weren't there yesterday, feel free to claim an account that doesn't currently have a name next to it. And just keep that in mind because it will come up later today in the workshop. And if you are putting your name down for the first time, please also put it in bold so we know that you're here today and you weren't here. Yeah, you're here today and you're going to use that account. Okay, so I'm seeing lots of bold names in the sheet, which is always excellent. In that case, it looks like everyone is pretty much ready to go, ready to set up. How are you feeling, David? You happy to take over at this point? Okay, well, while we wait for David to get it set up, we seem to be having some technical difficulties, but that's okay. That happens in a live session. So we are going to be using another tutorial, like for those of you in the Intro to Unix workshop yesterday, we're going to be using another tutorial like that. So I will paste the link in the chat. And if we can get you all to go to that, that would be great to follow along, because it helps if you're following along on your own screens as well as watching me and David. So in this tutorial, as I said, we're going to be covering version control, covering Git. We really want this to be a kind of hands-on practical session for you so that you can get familiar basically with working in a distributed way. And this is great because you're all obviously going to be working on the supercomputers, you're going to be working on Photonics and Nimbus and various other things. And it very, very quickly can get very, very complicated with all sorts of different files created and edited at different times on different systems. So Git is really one useful way to manage all of these files and to ensure that you're not getting conflict because you're editing something on Photonics and you're forgetting about the version you already have sitting on your local machine. So we really want this session to be we really want to give you the tools that are going to make your projects much more streamlined, keep you happy and keep your supervisors happy. So I think we're going to get started. Well, first of all, we're going to get started with setup. So I will share my screen. Oh, David started sharing. Excellent. I'll take that as a sign. David, would you like to take over here?
Can you hear me? No?
Ah, I can hear you. You're a little bit quiet, but I can hear you.
Okay. Yep. Hang on a sec. Hang on a sec. God damn it. How about now?
Amazing, loud and clear.
Yep. Love having to add gain at software and hardware level. Good times. Okay. So, version control. So, to make sure that we're all set up, and I will be looking at everyone in chat for this, is do we all have the git command installed on some kind of shell? I know from the bash workshop that you all have a bash-like shell. So if you can simply type git -- version and see that it returns some number or something and it doesn't say error command not found, because if you don't have git, we can't do anything. So I want to see a thumbs up from everyone. Okay, I'm seeing a few. Seeing a few. Yeah, that's a few more. Please keep your thumbs up, guys. So yeah. Okay. Okay, I'm gonna start. Yeah, keep those thumbs up. And I'm not gonna move on until I see all the thumbs, or I'm gonna start picking on you. If those of you who were at the Intro to Linux workshop remember how that went. Oh yeah, it looks like the thumbs go away automatically. That's my bad. Okay, I think that's enough thumbs. I think we're happy and we can move on. So, version control is kind of like the not dumb way of keeping track of things, because it's all well and good when you're the only person working on something, and even when you are the only person working on something, you change things and you'll break things and you want to go back to previous revisions. And version control is kind of a way of keeping things sane. And it's, in my opinion, it's what makes software engineers and software people much more productive than everyone else, because change management and change control procedures are an absolute living nightmare. So essentially, what we're dealing with is a system that we track changes to files from one version to the next. And the concept of a version really comes under a bit of scrutiny when we're talking about Git, and it's a bit interesting. When it comes to version control of code, which is just text files really, there's been a bit of a long and complicated history. Some people may remember Subversion or CVS. Both were awful, horrible systems. In fact, one of my supervisors did their honors thesis on version control. However, since then, we've had the program called Git released, and Git has basically taken over the version control space and is now the standard. It's not even a de facto, it's just is the standard. And every other version control tool out there either takes heavy inspiration from Git or is interoperable with it. So that's the main point. I'm going to skip the exercise here because it's not particularly important. So when we're going to talk about setting up Git, there's a few things that you need to do before you can start pushing and pulling to remote. So if you excuse me briefly, I'm just going to set up I'm going to set up something so that I can go over the setup with you. But until then, does anyone have any questions about version control?
Sorry, I don't think I actually have Git. Where can I get it from?
What operating system are you on?
Windows?
So you're on Windows. If you're on Windows, I'd recommend you install Git Bash. So if you go Google install Git Windows, it should come up to a link of Git SCN, which will prompt you to install Git Bash.
Okay.
So, okay, that's not going to work, is it? Yeah.
Sorry, David.
Sure.
I just thought I wasn't sure who asked that question, but I thought I'd just ask if they have the Windows subsystem for Linux already installed on their machine.
What is the subsystem?
Don't worry about it then.
Okay.
We can chat about it later if you want to know more.
Okay. I've downloaded the Git.
Perfect. Sorry, David. Thanks.
That's all good. All good. Okay, let's try this now. So you'll see on my screen that I am now in a standard thing, and I have the Okay. So this is, we're really going through the project, we're installing Git. So if you have not used Git, can I just get a show of hands? Who has used Git before in a software project and already has some kind of Git setup? Okay, that's one. Okay, so that's a few of you. So for those of you who have used Git before and already have a Git setup, my apologies. This is probably going to be a bit cut and dry, but for those of you who haven't used Git before, you will absolutely be wanting to pay attention. So the first thing that we need to do is we need to set up our standard Git options, and the two options that Git uses when creating commits and doing everything is it needs your email and it needs your username. So we're going to git config and so when we specify the global flag, we're saying apply this to all potential repositories that we make, because Git does allow you to configure settings per repository, but by saying global, we're just enabling it for everyone. So I'm going to say global, and then we give it the value, so user.name, set it as my name, and then we should also set up user.email. Enter your email, and that will be all good. So there's a few other settings so those are the two mandatory settings that you absolutely have to have set, and I recommend everyone run this now with the email you use to set up your GitHub account and your preferred name. Just run that now. So the next thing we're going to do is talk about line endings. This is a bit of a more technical point that we don't really need to know about, but Windows and Linux have different ASCII characters for ending a line. On Unix and Linux-based systems like macOS, it's /n, but on Windows, it's carriage return, so /r/n, and this causes all kinds of problems when you work on it. This can cause problems when you work on a code base that is shared between Windows and Linux. So my recommendation is just to do git config global core.autocrlf. So that's control return language format or whatever. You set it to input. So that way, if you work on a Windows code base on Linux, you're not going to be changing all the line endings and having thousands and thousands of changes to all your files and causing all kinds of horrible conflicts. But if you're on Windows, you want to set it from input. Instead of input, you set it to true. Because Windows doesn't deal with files that aren't CRLRF terminated. And then the final, there's a few more config options that we want to consider. The next one is going to be your editor. So if we go git config, does this show me git config? Yeah. Okay, I don't even have Vim. So my preferred text editor for editing Git diffs is Vim. For you guys have been using Nano so far. So what you want to do is, or if you like using VS Code or another one, if you're following the workshop instructions, I just copy and paste the command that has your preferred editor. For me, this is going to be Vim. So I'm going to put in Vim. If you've installed by git bash or on just installed it via the command line on Linux, the default will be Vim. So if you don't change it or configure it otherwise, you may need to know how to exit Vim.
Oh, we may have lost David for a second there. Can anyone else hear me? Is it me?
I can hear you.
Yeah.
What do you do for the auto CRLF for Mac?
Oh, yep. So we have that. It's the same for the Linux. So you want auto CRLF, just input.
Input, okay.
And it's because Macs, play nicely, Macs have the same line endings as Linux.
Sure.
Windows is the odd one out.
Thank you.
What did David do after the CRLF thing? I lost you.
Okay, so we did auto, so that sets the line ending. The next thing that you want to do, so we have this, if you pull up the Pawsey-Internships page that I shared with you,
yeah.
The next thing we do is pick your favorite editor. And all that does is that means if you need to, we'll see later, you can make changes to settings in Git, and setting your favorite editor just determines how those changes are going to be opened up for you to edit.
Right. So if I want to use VS Code,
Yep.
what do I do?
Yep. So we've got a VS Code option down the bottom on that page there, but I'll put it in the chat as well. So that's what you would put for if you want to use VS Code.
All right, I see. Thank you.
No problem. Yep. So David is going to be using Vim because that's kind of a standard thing that most people seem to have. Would you recommend that we learn to use Vim over Nano? Honestly, there's not much difference between the two. So Vim's commands, okay, this is testing my knowledge here. I think if I recall correctly, Vim is older than Nano. Its commands are different. I find it a little bit more difficult to use because all of the commands are keyboard shortcuts, whereas in Nano, you can use your arrow keys to kind of navigate around the document like you could in a Word doc or a, whatever standard text editor you're kind of used to now. I would say I think it's fair to say almost all systems now are going to have both. So I would probably just stick with Nano if it was me personally. I've set my default editor in Git to Nano because I like it more. But you can always Google Git, you can always Google Vim commands if you need them. So long story short, no, I don't think you need to know both. Any harm to using VS Code? No, I think VS Code is great. VS Code's just a newer version of Nano, really. It has some nicer graphical user interface, got some nice bells and whistles. We will actually be revisiting VS Code later in this Git session towards the end of the day. So if you do already have it, that's great. If you don't have it, you don't need to worry about it. It is just another nice tool to have if you're doing lots of work with Git and coding. So long story short, no harm. VS Code's good.
Emily,
yeah.
So that command you put in at 9:55, that one is what we have to put in after the auto CRLF one.
So you don't have to put that one in, Helen. That one is if you want to set your default editor to VS Code.
Oh, okay. So I've got that VS Code installed as an app. So do I still need to do that or? Yeah,
so you will need to do that if you want Git to basically open up any config files in VS Code when you edit them.
Oh, okay. But so that's more for if you're going to use VS Code on your project.
Yeah, honestly, at this point, setting the default text editor, it's just kind of a preference. It's not actually going to affect anything that we're doing today. It's just whatever you like to edit little text files in, really.
That one where you said code -- wait, that's for the text editor.
Yep, so that's for VS Code in particular as a text editor. There are other options if you want other text editors.
So for Nano, you just leave it?
I believe the default is Vim. So if you want Nano, again, this is in our website, but I'll put it in the chat with a helpful heading this time. So to set Nano as the default, you want this.
Okay. But you can just easily go back and change that at a later time. All right.
Yep, absolutely. You can change this whenever. We're just trying to set it all up a little bit now, but yes, can be changed at any time.
Oh, thanks.
No problem. Okay, so while we wait for David, I might share my screen and we will press on with the tutorial. I'll share my whole screen. Okay, so yes, so this is what we were just talking about. This is all of the different options to set different text editors as your favorite one. So David set Vim as his. So this little note here is just if you choose to use Vim, this is noting that it's different to Nano and different to other text editors. So there are specific commands you need to enter to exit it. Basically use :WQ. And the W tells Vim to save the changes you made in the text file, and the Q is quit. So the Q is a lot like we saw in the Unix workshop yesterday. That's the same way that you would quit, say, a man page. Okay, then we have another note here about Git branch naming. And so this is kind of a convention thing. So in older versions of Git, I can't remember the exact version number off the top of my head. I want to say it's less than about 2.1. The default Git branch, which was kind of the main place where all of your current up-to-date working happened, was called the master branch. But that has some not so nice political overtones. So there has been a bit of a push in recent years to change this default name to main. So you might see throughout this terminal, sometimes we actually explicitly change that branch name from master to main. But as long as you all have reasonably up-to-date versions of Git, that basically shouldn't be a problem, because the default now in newer versions of Git is to just call your main working branch the main branch. Oh, we have many chats. Is git config. Aiden, yes, that's correct. Carl, awesome. Thank you for jumping in. Okay, we're all good. Yes.
Oh, sorry, Emily. So if we set it to Nano, is that going to cause problems through the tutorial? Like, is it going to be harder to follow along?
No, that'll be absolutely fine. I've got mine set to Nano just because I quite like it. It's kind of easy. It's in the terminal. There won't be many chances in this tutorial. We won't really need to use the default editor at all.
Oh, sure. Thank you.
No problem. Okay, so default branch naming, proxies. We've just put this little note on proxies in here, basically just for your information. You might find that you need to use a proxy if you're, say, working from a different country and you need to get into Pawsey systems. I'm not sure whether they require a proxy or not, but you know, everyone's used a proxy for uni or various other things at some point. And this would be how you would set up Git if you knew that you were going to be working through a proxy. So again, we don't need to do that here, but it's there for your information if you find you need it later. The last thing in this lesson is Git help and the manual. So if I wanted to check, let's go to a terminal. Let's make me in Bash so I'm the same as all of you. If I wanted to understand what's going on in the config, I would use the help flag. And then this is basically like a little man page for Git config. So it tells you all of the different flags you can use and what they do. So they're the main takeaways from this lesson. Shout out if you have any questions. If not, we're going to move on to the next one.
Very quick question.
Yes.
If we're using Windows subsystem for Linux, do we follow the Linux instructions or the Windows?
Yes, follow the Linux instructions. Windows
Awesome.
subsystem is great because it just means it's like a little Linux machine inside. Yeah.
Cool.
Okay, excellent. Next session. All right, now we're going to create our first repository. So we've got Git configured, that's all good. Now we're going to head back to the basics of Unix. We're going to go and make a folder where we're going to start doing some of our work. So that's a second terminal. I don't want that. All right. So I want you all, I think we're going to, oh my goodness, I have too many terminals open. I apologize. Zoom commands. Don't need that. You don't need to see my attempts at data reduction. Okay, we've got a clean terminal. Now, I want you all to go to your desktop, I think, because that makes life easier if we're all in the same location. I'm already there. Excellent. We're going to make a directory called planets. And then we're going to change into that directory. All right, now we've got our directory, but we need to tell Git that we want it to track this directory basically. And we do that with the git init command. So if we type git init, you should get this message, initialized empty Git repository. And so that just means if we do ls, nothing's there. But if we use our LA flag, we can see now we have this hidden .git file in this directory. And this just means that Git is now going to be able to store all the history for everything that happens in this directory inside this hidden .git file.
Emily, what does LA do again?
So if we do LSL, that lists, well, nothing here. So LS, the A flag lists hidden folders and directories. So anything that starts in a dot. And then if we add LS, if we add the L to that, then it lists all of the extra info about those directories. So all the read, write, access, who owns it, what group I'm part of, and the date it was created.
Cool, thank you.
No problem. Okay, so now we have our Git directory. We're going to check what's going on with the git status command. And that basically tells us what's happening in our local repository. So we're on the main branch. That's good. I suppose I should check here. Has everyone got a main branch? Has anyone got a master branch? Hands up if you got on branch master instead, because we should change that. One hand up. Okay. So the command to change it. Ooh, 2 hands up. I think we want to do git checkout b main. Yes, switch to a new branch main. So can I get you guys who are on master to enter that command for me?
So you know if you're on the main branch through that command config list, because it will show the default branch equals main.
So that config list, that will show the default branch that is created when you create a repository. To check in your repository what branch you're on, you want to use git status. And then it will tell you in the first line what branch that repository is on. Okay, so now we should all be on the main branch. We have nothing in our repository. We've checked our status. There's nothing to commit. It's very boring. So now we have a little exercise for you guys. And this is just talking about nested Git repositories. Oh, Alex, you still have your hand up. Is that all good? Is that just a leftover hand? Yeah. Okay, cool. Leftover hand. All
Sorry,
right.
Emily, could you show me how to get on the main branch? Because I'm also on the master branch.
Yeah, I got when I went git status, I had fatal, not a git repository. So I'm obviously doing something wrong there.
That's okay, Helen. That's just because you would have missed the git init command. That actually starts up the Git repository in Planets.
Okay, so because sorry, I just went and made a folder in my desktop. I didn't follow
That's all good.
instructions.
So you should be in your Planets folder, first of all. Are you in there? Okay, so I'm hoping everyone's in their Planets folder. You should have done git init to make the Git repository. And then I had another question. Was it Brittany? Did you have another question for me?
Oh, no, I'm good, thanks.
Good. Okay, excellent. So now we have this little exercise on creating Git repositories and nested Git repositories. So everyone, you should have the web page open. I want you to have a read through this, and then we're going to chat about it.
What was the story for switching from master to main and that kind of thing?
Oh, yep. So to switch from master to main, we want to go git checkout, and we want the B flag to tell it we're checking out a branch, and then we're going to call it main.
Awesome, thanks.
No problem. Okay, so now in this little exercise, we are in our Planets directory.
Sorry about this, Emily.
Oh, no problem.
Could you bring that up, because I'm in master as well.
Okay, yep. It's just this command here, git checkout.
Okay. Git checking.
Yeah. So git checkout, the B flag is for branch, and then we're going to call it main.
Switch to new branch main, yeah.
Yep,
Okay.
excellent. So now if you do git status, you should see it's on branch main. Okay, so now we're in our planets directory. Who are we here? Dracula. Okay, so Dracula has made a new directory called Moons in the planets directory, and he's CD'd into it, and then he's made another Git repository. So the question is, do we need to make another Git repository inside the subfolder Moons? Oh, I have some chat too. I'll check that. Oh, Kevin, does the Git repo now have 2 branches? Good question. No, short answer, no, it doesn't, because we have switched this out before we've done anything with the Git repo. If we had gone ahead and made lots of folders, made lots of text files and then switched, then we'd probably have a problem, because we have all of these changes that were previously associated with master and now we've switched on to main. But because we're changing it right from the get-go, we just have main. Why would we change from master to main? Yao Yu, good question. Really, it's just a convention. All of these central branches used to be called master, but we don't like that terminology because it has some political overtones, and basically it has political overtones that we don't like. So the Git community is shifting away from master and towards main as the name. And thank you guys for helping each other out. That's really great to see. That's what we want to see. Okay, now back to my exercise. Has anyone had a thought about this? Do we need to create a new repository, Git init again, inside Moons if we've already done Git init in planets?
No,
No, excellent. Why not?
because it already tracks changes for the whole directory in planets. Yeah.
Yeah, perfect. Yes. So as soon as we do Git init in planets, as Carl said, this is going to track everything inside planets, any other subfolders, any files within subfolders, files within subfolders within subfolders. So we only need to do it once. And in actual fact, things get messy if you try and do Git init inside a folder that already has a Git repo associated with it, because that means you basically have Git trying to track changes twice on that inner subfolder, which can get really messy. So if you want to have multiple Git repositories, make sure that they're in separate folders and they're not nested inside each other. That's the warning there. And then we have a little warning about Git init mistakes. How can he undo? Dracula would like to remove the nested repository. How can Dracula undo his last Git init in the Moons subdirectory? Okay, does anyone want to shout out how might you remove a Git init in a subdirectory if you've accidentally made one?
Is it Git uninit?
The RM.
I like your thinking with the Git uninit, but yes, in this case, we are just going to RM the .git file. It would be nice if there was an uninit option, but unfortunately that doesn't exist. So yes, I think that was Helen calling out. Yes, that is correct. We're just going to RM the .git file. So let's say I did that. Let's say I'm going to make dear Moons inside here, CD into Moons, and there's currently nothing here, but I'm going to Git init. And then I've got Moons, whoops, ls, la. But oops, I already have Git inside my planets. So I'm just going to go rm.git. Whoops, and it's a directory. So I need the R flag, rm.git. And now if I look in there again, there is nothing there. Yep, whoops. Yes, excellent. Okay, do we have any more questions? I will just check the chat. Yep, okay, we had other solutions, rmdir, yes, that would also work. RM, so with the F flag is good, but we would still need the R flag because the .git is a directory, not a folder. But otherwise, yes, that sounds good.
Emily, you know how before we ran a command, what was it? Global init default branch main.
Yes.
How come that doesn't cause the master to be in? Oh, it's still called, like mine was still on branch master when I created the Git before.
That's a great question. I'm not sure that I have a good answer for that, because setting the config. So when you do git config -- list, you do get the init default branch main.
Let me try that. Git config -- list. What am I looking for?
You're looking for init.default branch.
Yeah, it's equal to main, it says.
Hmm.
But then when I made the new git init inside the moons folder, it still comes up with master, not the what status shows me on branch master.
You know, that's a real pain, Carl, and I don't think I have a good answer for that one. I'm sorry.
That's okay. I use the like GUI normally, not terminal. So
Yeah. Okay. Yeah. I mean, it might just be something you're going to have to keep an eye on.
Yeah.
Yeah. Yeah. I don't know. That's Git being weird. Sorry about that.
Okay.
Okay. We've got something in chat. What if you want to switch to master again? And yes, Daniel has answered that. You can check out branch master. But really, you shouldn't need to change back to master at all, because everything should be on your main branch. Master is an empty thing that in newer versions of Git won't even exist. Awesome. Okay, let's move on to our next lesson then. So now we're going to start making some changes and tracking some changes. So we want everyone to be in our planets folder again. Is that where I am? Yes, it is. Okay, now we want to make a file. So use your favorite text editor. I'm going to use Nano because I quite like it, to make mars.txt inside here. And we're going to put some output in there. So I'm going to be very unoriginal and just copy what's in the lesson. Cold and dry, but everything is my favorite color. I guess it makes sense if we're supposed to be Dracula and Dracula likes red. But I'm going to spell color with a U. Okay, if you're using Nano and you can't quite remember it's Control-0 to save, enter, and then Control-X to exit. So now ls, we have Mars, cat mars.txt. It has our little line in it. Okay, so now we're going to try doing git status again. And you should see, if your terminal is nicely colored like mine, you'll see that we're on the main branch, but we have this untracked file, mars.txt. So that means that Git has recognized there is something in our directory that's new, but Git is not currently tracking its changes. So now we need to tell Git that we want to track this, and we do that with the git add command. So we're going to do git add mars.txt. So now, if I do git status again, I will see my file's now in green, and it says that there are changes to be committed. Now, this means that I've told Git I want it to track the file mars.txt, but it's not actually recording any of the data yet. It's just aware that this is something that it should be tracked in the future. Hopefully that makes sense. So now we actually want to let Git record the changes that we've made. And we do that with the commit command. So I'm going to go git commit, and I'm going to use the M flag. And the M flag means record a message with my commit. And ideally, you want this message to describe the changes that you've made so that when you go back and look at the history, you can see exactly what you've done at each point in time. So I'm going to say I guess I'll copy the tutorial, start notes on Mars. And we're going to, we're going to put that in double quote marks. Again, for those in the Unix workshop yesterday, that's because we don't like spaces in Bash. And the double quote mark solves our spaces problem. So now you should have start notes on Mars as a base. We have made our commit, and it says we've got one file changed, one insertion, and we've created the file mars.txt. Can I get thumbs up if we're all good to this stage? If not, shout out with questions. Thumbs up. Awesome. 1 thumbs up, 2 thumbs up, 3, 4. Oh, many thumbs up. Excellent. Okay, I'm hoping that's a good sign. Let's move on. Now, if we look at git status again, we're going to see on main branch, nothing to commit, working tree clean. So that's good. That means that Git is all up to date. It has recorded all of the changes that we've made so far. The other thing we've got here is git log, which you can try out if you want. It's kind of a bit boring at the moment. It just shows us all of the changes that have been made in our history. So I only have one change, which happened today at 1:18 p.m. because I'm in Sydney, not in Perth. And this is my little commit message. I started notes on Mars. So now we're going to try making some additional changes to our mars.txt file. So I'm going to open it in Nano again. And I'm going to be very boring and just copy and paste this line from the tutorial, but feel free to add your own text. We might have little stories about Mars. Whoops. We might have stories about Mars by the end of this. So I'm going to add, what did I do? I added that to the wrong line. Okay, we're going up the top. That works. Control O, Control X, and I have chat messages. Ah, yes. Again, awesome. Thank you guys for picking it all up. Yes, cat is just for viewing. Okay, so nano Mars. So now, now if I do cat Mars, we can see I have my 2 lines that I put in there. But if we do git status, we have again changes that have not been, that we've not told git yet that we want to record. So does anyone want to shout out how we're going to, well, I guess it tells me in the command line, but does someone want to shout out for me? How am I going to add these changes and tell git I want to track them? I'll pick on someone. It's right there. What do I have to do? What's my command? Git what?
Commit the changes.
Yes. Well, commit the changes, yes. But is that first? Okay, so well, yes, but first I need to add my file to this commit. Because if I just do commit at the moment, if I just try git commit message, yes, commit, it's going to tell me that there are no changes to added to commit. So every time I make a change, I need to add it to my current commit to tell git that I want to record it, basically. So I'm going to git add mars.txt again, git status. And now we can see that my text file turns from red to green, which means that it's now ready to be committed. So now I can go git commit message updated Mars. And now we can see our commit is successful. We've got 1 file changed, 1 insertion. Ooh, I've got some messages in chat. Yes, Daniel, very good. You can also do git commit with the A flag, and the A flag just means add everything. I will say, bit of a caveat, you probably should be careful with just adding everything at once. Particularly when you first start out, you probably want to add things manually, just so you know exactly what's being put into a commit. But, you know, people get lazy. I'm a bit of a lazy programmer sometimes, so I also do use the A flag. So yes, Daniel, thank you for pointing that out. Is there a maximum comment length? Maximum standard comment length is usually 50 characters. And can you add multiple files at once to be committed? Yes, you can. Why don't we try that? So let's make another file called Jupiter txt, and let's make 2 files. Let's make Jupiter txt and Saturn.txt. Okay, so now if I do git status, I'll see that I've got 2 files there that have not been added to my commit. So I'm going to go git add Jupiter Saturn, git status, and they've both been added, ready to be committed. So now I'm going to go git commit message added Jupiter and Saturn. And it's done. So yes, you can add more than 1 file at a time. And as Daniel said, you can also just stick the A flag on and add everything. But just make sure you know what you're doing if you're going to do that. Okay, git status. Git diff is kind of a useful thing. I guess I'll mention it here. So git diff is whoops. What should I be doing? I should read the text. No changes added to commit. Ah, yes. Okay. So if I was going to make a change to Mars, so let's go back into mars.txt, and I'm going to add a new line. What's a good new line about Mars? It has, I don't know, it has ice. I'm pretty sure. Yeah, it has ice. We know Mars has ice. Okay, save, exit. Now I want to see, I can use the git diff command to see what, is this going to work? Let's try git diff to see what the differences are between my last recorded commit and the state of my folders and files as they are currently. So running git diff now we get all of this header output, which is, kind of useful. You don't need to worry about it too much. It basically tells you what files we're looking at for the difference. And this is just a reference to the history of those files. The most important thing is this bit down here, which is nicely color coded for you. So we've got this line in green with a little plus sign next to it. And that just shows that since I last committed to my GitHub repository, I have added this line saying it has ice. So now I think, yep, I want to keep that. I want to commit that to my repo. So I'm going to git add Mars again, and then I'm going to git commit. Okay. What else is useful?
Emily,
Yes.
if you git commit -a, you said that adds and commits at the same time, right?
Yes.
So if you don't give it, does that allow you to give it like a comment with it?
Yeah, so that will allow you to give a comment as long as you add the M flag as well.
Oh yeah, right, okay.
Yeah. Okay, that's all I think we need to cover from there. If there are any other questions, feel free to shout out. Otherwise, we have this handy little diagram in the lessons, which basically shows how this commit process is working. So basically you make edits in your file. We've got this little green line here. So this is something you might have added. Then you use the git add command to add this file to what's known as the staging area. So this means you have told Git you want to record these changes, but you haven't actually told it to do the recording yet. So then with git commit, we add what's in the staging area into the repository, and we tell Git to actually record the changes that we've marked. Git diff. Yeah, and this is pretty much all the same thing again. So I don't think we need to go through it again. We've done lots of committing at this stage. Git status, git log. Okay, so I guess the other thing to check now, if I do git log, you will see that I have, I might clear my output so it's a bit easier for you to look at. If I do git log, you'll see that it now records all of the commits that I've made to my repository since it started. And it tells me the comments that I made to each of them. So this is a really good way to check out what you've been doing, in the recent history of your project. So yes, we have a little note here. You can call git commit without the message command. But if I do that, it's going to come up with a text editor. And so this is probably, yes, so this is of interest perhaps to Helen and others who are asking about your favorite text editor. So if I edit mars.txt, I'm running out of facts about Mars. Let's say it once had liquid water, because we're pretty sure that's also the case. So now I'm going to git add my changes, and I'm going to git commit without the message flag. It's going to open up Nano for me, and it's going to give me an option to add a message here rather than doing it on the command line. So okay, I'm just going to say added fun fact report. I'm going to save that and I'm going to exit it. And so now my commit has been added with the comment that I put in the text editor. So the -m flag is basically a much shorter way to do it, makes life easier. But if not, if you forget to put it in, you're still going to be prompted to enter a comment, because that's good coding practice.
So the add command essentially lets Git know that you want to incorporate new changes to your file, and then the commit basically makes those changes, and you can add like a message to the log, letting you know what you've done, so you can go back and see.
Yep, exactly.
Is that right? Okay,
yes.
cool.
Yep. Awesome. Okay, now directories. What do I want to say about directories? Yes. Okay. So Git on the whole does not track directories if they're empty. So if we make another directory inside planets called spaceships, and we go git status, it's telling me that there's nothing to commit. The working tree is clean, even though I have added the directory spaceships since I last committed and tracked my changes. Even if I go git add spaceships, add the directory and git status, okay, I'm still saying that Git is still telling me that there's nothing to commit. And that's because Git basically wants to be efficient. It's not going to bother tracking an empty directory because there's nothing in there to make changes to. So if you want to track a directory, you need to add some sort of files to it. So let's create, what are we creating? Apollo 11 here. So we're going to create spaceships, Apollo 11 and spaceships, Sputnik 1, lovely. And I have a comment in chat. What's my comment? What is meant by A and B? Ah, great questions, Aiden. Okay. So the question is, for anyone who's not reading chat, what is meant by the A/ and B/ in diff git? Okay, so if I go, let's go git diff here. Is that going to work? No, it's not going to work. Let's go git. Okay. The A and the B is basically just telling you that there are two files called mars.txt in different locations. The A and the B don't actually point to specific directories. It's just a placeholder telling you that they are in different points in the history. Yes. Okay. So now let's look at our status now that we've added things to the spaceships folder. We can see that Git is picked up. Now it's telling me, okay, now there's something that could change in spaceships and I'm not tracking it at the moment. So now we can add the whole directory. We can just git add spaceships, git status, and we can see now it's telling me, okay, I found two files in here and I will track their changes. So now if we do git, oh, that's not going to work. Okay, that's right. Now if we do git commit m, add some spaceships. We have our two files within the spaceships folder are going to be tracked. Lara, so Git is only worried about files and not the directory they're in. It's a good question, Lara. So yes, Git, in a sense, yes, Git is only cares about the changes that actually happen within the files, but it is going to track the structure of the directories. So it has tracked that these files, Apollo 11 and Sputnik 1, are in the spaceships directory. But it really only cares about the actual changes that are happening to the files. Yes. Does that make sense? Awesome. Yes. Does it track changes to the folder structure? It will track changes to the folder structure if you have changes to the files within the folder structure. So if let's say, what can I do? Let's go into spaceships. And let's make a new directory called American spaceships. And I'm going to move Apollo 11 into American spaceships. Okay, so now if I do git status, Git's saying, well, the Apollo 11 file no longer exists because it exists in the spaceship directory. But I have this new directory called American spaceships that contains Apollo 11. So I think I should track that. So now if I do git add, and here I'm going to be a bit naughty. I am going to use the A flag. No, sorry. I would do that for git commit. I'm going to do git add and I'm going to do dot, which tells me I want to add everything in my current directory. So now I go git status and we can see that everything's turned green. Life is good. And it's actually picked up that the file Apollo 11 has been renamed as Git sees it. So it's moved into a different directory, but Git sees that as its full name of which its file path is part has changed. Does that make sense? Yep. Okay, excellent. So now we've added folders, we've changed things. What else do we want to say here? To recap. Yep, so this is just another diagram showing the same thing. We make some changes to files. We use git add to tell Git, these are files I want you to track. I want you to track these changes. And then we use git commit to actually record the changes. We've got a little message here about choosing commit messages. It's a little exercise. Which of the following commit messages would be most appropriate for the last commit made to mars.txt? Well, that's a bit confusing because I have added lots of things that we haven't in the tutorial. I have ice and water in my file. But basically, moral of the story is here, you should be using commit messages that make sense to you and that capture the changes you've made, because you want these to be useful when you come back later and look at your history. Okay, now we have an exercise which you can all do, committing changes to Git. So I want you to have a read of this and then we will have a chat about it. Okay, so hopefully you've had time to read through these. Does anyone want to shout out which commands below would save the changes in my file.txt to my local Git repository?
Number 3.
Number 3, excellent. Yeah, Brittany, was that Brittany? Do you want to
Oh,
explain
Laura.
why? Lara, sorry, Lara. Yes, would you like to explain why?
So first you have to add the file, and then once you've added it, you can commit it.
Yes, exactly. Yep. So we've got to tell Git that we want it to track this file before we make the commit. Perfect. And committing multiple files. You guys are already on top of this. Someone already asked about it and we covered it. So you can commit multiple files at once. That is all good. And we don't need to worry about creating a new repository. That's okay. You can come back and do these exercises later if you want to, but I think we're just going to press on with the next one, unless anyone has any questions or you really want to make a new repo. Up to you. But I will take silence as agreement to move on. I'll give you 5 seconds to decide. Sounds like silence. Okay, let's move on. All right, exploring history now. So as we saw in the previous episode, we have commits and they are, so I suppose that's something I should cover a little bit more clearly. So these commits are all tracked by, basically by little identifiers. So if I look at, let's look at git log. So this really long string here in each of my commits is its unique identifier. And this is going to be unique to the machine you're working on and the exact commit you make. So it's a useful way to go back and reference these commits if you want to see what changes you made at a particular point in time, basically. And we can use the git diff command to start to explore this. So the first thing we're going to try is git diff head mars from the tutorial. We're going to go git diff head mars.txt. Now head here is actually the name of the most up-to-date commit that you've made. So that's called the head of the branch. So if I go git diff head what did I do? Git diff head mars.txt, ambiguous argument mars.txt. Interesting. Ambiguous argument, unknown revision or path not in the working tree. Okay. Is that because, where am I? Maybe it's because I'm in here. Yes, okay. So I was getting that message because I was not in the location of mars.txt. So Git didn't know what to look for because it didn't exist in my current directory. But now if I do git diff head mars.txt, I get no output because my repository is all up to date, basically. Git status, nothing to commit, working tree is clean. So now if we go in and add something to mars, txt, I'm really running out of facts here. I might need to get you guys to shout out some facts in a minute. It is the closest planet to Earth. Control X. Okay, so now if I do git diff head mars. Okay, now I'm going to say, now I get this again. So there's a difference between the mars in my current folder and the mars file that was last committed to my repository. And again, it's nicely color-coded. It's showing that I added this line since I had last committed changes. The other useful thing that you can do is you can also look at commits further back than the most recent one called head. Oh, I have a comment. Mars is big. Awesome. Thank you, Aiden. I'll use that one next time. So yes, we can look at commits that are further back than the most recent one. And we can do that by combining head with the little tilde character. So if I want to look at, let's say the one before head. So that's not the last commit, but the one before. I'm going to do git diff head, and then I'm going to go tilde1, which is basically like saying head -1, mars.txt. And that's a bit boring because nothing much has happened there. So let's do git diff head 2. That's also a bit boring. Okay, but you get the idea. If I could go back, I don't know how many commits I have. Okay, yes. So if we go back to 5 commits before the last one, 5 commits before head, I can see that 5 commits ago, these 3 lines weren't in my mars.txt file. So it only had the first 2 lines there. So does everyone want to give that a go? Test out some different stages of commit from head tilde 1 to head tilde, I don't know, 3, however many you have. Have a look at the output and make sure it makes sense to you. Shout out if it doesn't, or if you have any other questions. And if not, the other useful thing that we'll cover is if we look at git log again. So I mentioned before that these really long strings next to the commit can be used to identify that commit. So here we can see this last one, this is head, but it can also be identified by this great long string here. So another thing you can do is you can do git diff and use this ridiculously long string identifier to take a look at it. So let's say I want to look at this commit here. So let's copy this. I'm going to go git diff blah mars.txt. And we'll see, okay, since this commit, I had added these 2 lines here. Now they are very long and really unwieldy to deal with. So the other thing we can do is we can get rid of all but the last sort of 6 or so characters, and that will still work. That's still enough to identify that commit. Oh, we have some comments in chat. Git diff head will compare which 2 versions by default. Yeah, so, David, amazing. Yes, your current stage changes to the last commit on head by default. Yes, that sounds right. Okay, so where are we up to? Git diff. We can use a short name. So now we can, what are we doing here? Okay, so now I'm going to have changed my mind about some changes. So let's make some changes I don't like, first of all. Let's go git. No, I don't want to do git. I want to do nano. Mars.txt. Okay, I'm going to make a mistake in my file. And then I'm going to not realize that I made a mistake, and I'm going to commit it.
So just a quick note on git chars. So you'll see those big long identifier strings. Internally, that's like a hash of the changed content that you made. And you'll notice that the commands either refer to the full commit char or like a reduced condensed commit char. Both are valid because it's just sufficiently unique. And if you don't specify enough characters to show a sufficiently unique char, Git will let you know and say, please, I can't uniquely identify this commit. Please give me more commit characters from the char. So just in case you're wondering of why we're using this short stuff as to using the full long one.
Does it have to be from the top of it, like the first?
Yeah, it must be from the beginning of the commit char. So the first n characters. And so Git guarantees, I think it's still using SHA-1 internally, guarantees uniqueness of the full hash, but it does not guarantee uniqueness of the first 6 characters. But normally in most projects, the first 6 characters is going to be more than good enough because you're already at like 10 to the something possible combinations. Yeah, that's all. Sorry.
Amazing. No, thank you, David. Good to see you back too.
I love Perth internet.
I might just finish up this one, then I might throw back over to you, if that's okay. Okay, so where were we? We've done git. Yes, so we're committing our poor choice. Where did we get up to? Da-da-da. Where am I? Git head, git show, git diff. See what we get. Oh, that's the start of the lesson. Sorry, I've lost my place. Git diff, git branch, git checkout. There, that's what we want. Okay, yes. So we're committing my poor choice, and that's done. And then I decide, actually, that was a big mistake. I don't want to do that. So if we wanted to go back to the way, oh, actually, I think I've done an oopsie. I've committed, and I shouldn't have. That's okay. We're not quite at the stage of undoing commits yet, but we can do that. We can still fix this. Yes, we can still fix this. So if I wanted to undo this, I can do, Oh, this is testing my knowledge now. Can you give me a hint here, David?
So, so the way I like to think about the whole head, you can just think of the commits as like a series, as like a graph, like a line in time. And like when you do the tilde, you're saying go back in the line. So head is the start, the head of your graph. So if we want to go back a commit, we go head tilde1, which you've seen worked with git diff. This works with every single git command. So git diff is showing its head, whereas git checkout is kind of say, move the current state of my file system, my working directory, my git repository, move the whole state of that to this commit. So if we go git checkout head tilde1, that will take us back one commit.
Yeah.
And so now you can see head is now at 7D, which means our head was here before, we've moved the head back one. And so now if you go git log, you'll see that our mistake is no longer there because we've reset our head.
Yes, amazing. Thank you, David.
And that doesn't mean that your mistake commit is gone. It's still in the Git database somewhere, but that's a much more advanced topic. So something that I want to let you guys all know at this point is that if you put something into Git, it is very, very, very hard to lose it. Like you can do some weird stuff with Git, but it's almost certainly still there, and it's just about how to get it back out. So don't worry if you're like, oh, I went back too far, or oh, I've deleted this thing. Unless you actually delete it from the Git history, which is very hard to do, it's still there.
Amazing. Yes. So David has come to the rescue and fixed me. I have now reverted my changes that I committed, but let's say I make a change and I don't get as far as committing it because I'm a little bit smarter than that. So I'm going to edit Mars again, and we can see that my mistake is gone now, but I'm going to add another mistake. And I'm going to get to the stage of adding it, but not committing it. So I'm going to add mars.txt and git status. Now, you can see here, I get this little prompt, git restore stage to unstage. So I can absolutely do that. I can do that to undo a change that I have not yet committed. You may see something else. You may see git checkout, I think, depending on your version as well. And that works fine as well. But I'm going to follow the prompt here. I'm going to git restore.
So for context, the commands git restore and git switch have different, were only really released in Git like version 3 to something. So and essentially they're just aliases for checkout, but they make more sense intuitively when you write them. So it doesn't matter which command you use, they do exactly the same thing because internally they call the same functions. It's just if git restore makes more sense to you to type, then use that. If git checkout makes more sense to you because you have the internal mental model of Git, use that.
Yeah, exactly. Thank you, David. So now I can see if I go back if I look at Mars, I don't have my mistake line anymore. See that, so it looks a bit neater. We can see that my mistake is no longer there. Life is good. So there, how to undo mistakes if you do make them. It's always possible. What else do we need to know? So we've talked about, yes, checking out different. So you can check out also different versions of mars.txt. Oh, we have some questions in chat. What was the line to move? Yes. Yep. Yep. So you can use git restore or git checkout. Either one is good. Don't lose your head. Yes. So this is what we covered before when I made the mistake of erroneously committing. You can check out an entire previous commit of your repo, as I did, to undo my committed mistake. Yeah, you've just got to be careful when you're doing that you know what you're doing. So if I do git status now, it's going to say head detached because Git has picked up basically that I've gone back to a previous commit and there is something further ahead called head. So I'm just going to git commit again. Oh, head detached. What have I done? commit working tree clean. Head detached. Ah, okay. I think I know what I want to do. Let's go. Okay, yes. So now we're good again. Now life is good. Let's just check cat.mars.txt. So now I've got my mistake back because I've switched back to head, but I want to check out a previous commit of just a single file rather than of the whole repo. So let's look at git log. We want this one. Let's take the first little chunk of this. And then we want to go git checkout. I want from this commit, I want mars.txt. Now I do git status. Okay, we can see that that's been modified and we're going to commit. And we're looking good. And let's look at Mars. And we've fixed our mistake. It's no longer there. Life is good. What was the issue just then? Okay, my issue was I had done git checkout to look at a previous commit, but I hadn't specified a single file. I just go on git checkout, give me the whole repo as it was 3 commits ago or whatever. And Git kind of doesn't like that because it's saying, well, I know that there's a head that is further down the line that has more changes than in this previous commit. So it doesn't like that. So if I know that I've only made a mistake in one file that I've committed, I can use git checkout, the commit number, and then I put in the file that I want to check out specifically as part of that command. And that's telling Git, I want to go back to a previous version, but only of this file rather than the whole repo. And Git's okay with that. Then you can just git commit and keep the previous version of your file.
So, yeah, to elaborate a little bit, when you use checkout, if you don't check out to the head of a branch or a specific ref spec, Git's going to be like, you're in a detached head state, like you're within a commit chain, but you're not at the head of the commit chain, so I can't do things because Git only modifies the head of the commit change unless you do fancy things. And so, what I told Emily to do, which was go git checkout head.1, is a way of removing the mistake there. And that wasn't totally correct because what we would have had to have done is we would have had to have created a new branch there. What we should have done instead is this command called git reset, which is instead of looking at a commit previously, it actually says, no, go back to that particular point. So to undo a full commit, it would actually be git reset head-1, not git checkout. That's my bad. I forgot we were trying to not unstage changes as opposed to undo commits. So, but we're not really going to cover git reset. Yeah, git reset head-1. Like that's kind of like a brute force way. We are going to cover the way that you should do it, which is actually git revert. And so instead of like resetting the git history, you just revert the changes in a commit. And that's a safer way of doing things as opposed to rewriting history. But that's just for understanding reset makes more context in the context of checkout. I believe if anyone has different opinions, feel free to correct me. Yeah.
No, yeah, I think that sounds perfect. Thank you, David. Point is we got there in the end. So what else do we need to know here? Simplifying the common case. You'll carefully see. Yeah, so some of you, this is what I was saying before, some of you might see git checkout file to discard changes that have been staged. I see on my version git restore, and as David said, these are basically just aliases for the same underlying command, so you can use either one. And then, recovering older versions of a file. This is what we've just worked through. So I'm going to give you just 5 minutes to have a look at this first one. Not 5 minutes, we don't need 5 minutes. I'm going to give you 1 minute to have a look at this one, and then we'll chat about the answer, and then we'll move on. Okay, so hopefully we've had a chance to read through the question, and we've learned from my mistakes. So does someone want to shout out, how is Jennifer going to recover this old version of this file that she wants? Anyone?
She can use both 2 and 4
Yes, excellent. Why are both 2 and 4 okay?
because 2 removes the latest one
Mhm.
with the head, and 4 you can use the unique ID of the latest one to remove it as well.
Yes, amazing. Yes, excellent. So the unique ID in this case is going to be the same as head. It's going to point to the same part of the history as head. So yes, excellent. Very good. Okay, so reverting a commit, yes. And this is what David mentioned before. So this, did David mention this? I think David mentioned this before. So this is a nice way to revert a commit. If, like me, you went all the way to the stage of making a commit and then realized, oopsie, I didn't want to do that. The nice way to do it is to say git revert and then name the commit that you no longer want. So let's have a look at this exercise again. Let's give it 1 minute and then we will chat about it. So we have some steps here. Jennifer wants to use git revert. What is missing from these? And it's really just this first command. Does anyone want to shout out? How would she look at the git history to find the commit ID that she wants?
Git log.
Git log. Yes, amazing. Very good. Excellent. Okay. Understanding git diff. I think, what do you reckon, David? I think a lot of this we have covered pretty well. I am happy to hand over to you if you want to start looking at the next section.
Yeah, there's just a few extra things that I'd like to mention. So down right at the bottom of the workflow. So git commit dash amend allows you to change your previous commit. So it takes the stage changes that you currently have and adds them to the previous commit, which can be very useful. So you say you accidentally forgot to update your test results as a part of a big feature commit, and you say, oh, I want to add my test results into that commit. You can, you just use dash amend. And if you write a commit message and you're not happy with it or make a mistake, you can go git commit dash reword, and that allows you to just change the commit message, not the content of the actual commit. Amending and rewording might not be the correct thing that you want to do, depending on the scenario, but just letting you know that those are there. And then the last thing I want to point out is that get help to undo almost anything, Seth Robinson's guide. I want everyone to click on that link. This is basically the, oh crap, I stuffed up how fix for most things in Git. It's very, very good. And it just asks you questions and it points you to the right way. It can't fix everything, but 95% of the time it can fix what you need. So definitely bookmark that, because it saved my bacon a number of times. Because there's a lot of weird things that you can do. So we're going to move on now to the ignoring things section. So let me just get this up. Share my screen. Okie dokie. So we're now going to talk about ignoring things. And the reason why is because I guarantee you in some of your projects, you're going to be, if you are using Python, you'll have this file called _PyScache. And you'll be like, what the hell is this file? And it's going to change a bunch. And if you start committing it, it's going to cause problems. And maybe you're in a Ruby project and your bundle, or if you're in a JavaScript project and you have node modules, or you're in a C project and you have all your object files. You know, the list goes on, and there's just so many occurrences where there's automatically machine generated files that change when you're building things that you just don't want Git to worry about. We want Git to worry about source code changes and only source code changes. And so the creator of Git had this in mind, and so we have a method of ignoring things called the git ignore, which is rather self-explanatory. So the git ignore is just a file that you can place in a repository that Git will read, and if you specify a regular expression or paths that you'd like things to be ignored in, and just Git will not track changes for those files. It just won't even tell you about them, which means when you run git status, those files won't come up and Git won't bother you about them. So I'd recommend, because I haven't followed everything, I'm not going to show you how to do this yourself, but we should add the lines.dat star.dat, which means if we remember our bash lesson, that just means expand every .dat file, and it ignores the results directory incompletely. So everything within it will be ignored as well. So we'll just put that into our git ignore. So the git ignore itself is a text file that is tracked by Git, so you will need to commit it to add this, but it makes your life so much easier. Now, if you want to see what things are ignored by Git in this stage, you can do just git status -- ignored, which is pretty obvious. I'm just going to see if I have a decent working example for, in fact, yes, I have a good example for you. Just give me a sec to set it up. All right. I'm going to stop sharing this screen because it's all pretty. So, what better way to show the power of git ignore than, oh, nope, that's, you know what, this is fine. That's not what I want to do. But you can okay, now that should look slightly better for people. So you get to see why I like using tmux. Okay, so what better example than to show you this entire workshop that we're doing is stored in version control. In fact, here it is right here. And if I go git log, you can see all the changes we've been making in this workshop for today. And so if I go git status -- ignored, if I can spell right, you can see there's a whole bunch of files that I've ignored in my git ignore. So if I go git ignore, yep, you can see that I'm ignoring the PyCache, the DS store. This is a specific thing for Mac. Any notebooks, JQuil things, the PyCache for Python, all this art history and data things, Docker vendors things, the gem file, which is just a version thing, and all this history. And so this is why we use it. If I actually show you what's in bundle, okay, maybe not. Vendor. So if I list the vendor, look at all this crap. I don't care about any of this. This is like 500 Ruby modules. Ain't nobody want to be committing this to their repository. So that's why we have git ignore. So what I'm going to do now is I'm going to give you guys 5 minutes to work through the exercises and the ignoring things. If anyone has any questions, let me know, and I'm going to start picking on people in a couple of minutes to give me answers. So apologies if I am picking on people who have already been picked on, but do I have any volunteers for question 1? It's easier if you volunteer yourself because it means I won't pick on you again.
I can answer it.
Go for it.
So you only want to ignore the results plots and not results data. So you just change your get ignore file to include the directory results plots and not results data.
Fantastic. Thank you. All right. Do I have a volunteer for question number 2?
Yeah, you put the star.dat, but ignoring all of them.
Awesome. However, what do we do if we don't want to, if there's a specific file we don't want to, we do actually want to track changes to?
Oh, okay. The hint was find the exclamation mark in front of final.
Correct. So, in the all-seeing wisdom, the creative Git realized that you might need to, there are things that you will ignore in a bunch of directories, but you in fact actually want to keep track of a specific file exactly, and so the exclamation point is your way of doing that. So I'm going to skip a few questions, and I'm just going to, because I think you guys are getting the point, given the fact that people are actually volunteering. So does someone want to answer the question, ignoring all the data files in the repository for me?
Would you just go like a star or something? Or just a whole directory with a dot?
Not quite. So if you have that directory, you need to, the key point in that question is without explicitly listing all the names of the folders.
So where are these questions? I don't see them.
So they're in the ignoring things. So that's episode 6, and it's the third from the bottom. Ignoring all data files in the repository.
Oh, right, I see. Yeah, like a asterisk, right? To do those ones. Oh, I guess inside the data folder.
Yeah, because that'll ignore everything.
Yeah, so you want to do it inside data, so data slash experiment 1. Oh, data slash star, I guess.
But what about the results directory then? We won't be ignoring that.
Yeah, I guess so then star. I don't know what the file tree looks like.
So I'll give you a little hint here. There's this nice little expansion called star, which in git ignore, and star says all the directories.
Right.
It doesn't matter how deep it goes, all the directories. And so what we do is if we go to star/star.dat, that says ignore all dat files in all directories, no matter how deep the directories go.
Right.
So if you look at the solutions, that's probably what it's going to be. It's going to be star/star.dat, and that's a really nice little hack. Instead of explicitly mentioning all these paths, when really you just want to ignore a specific kind of file, comes in quite in handy. So I'm going to pick on you, Aiden. What do you think about the order of rules question?
Yeah, that'll do nothing. That's literally just cancels the it cancels the ignore.
Awesome. So rules are the most recent rule going down in the file has precedence. So the not rule will take precedence over the normal rule, which is all good. And the last question, log files. Does anyone volunteer for this? I'm going to pick on you, Daniel, because I know who you are. If you're listening. Maybe, maybe not.
I'm listening, but yeah.
Okay.
I need to be quiet. So because let me just check the question pool. So it's going to be so that's about you wrote a script that creates many intermediate log files. So that's it. I lost the track. All right. So we'll need to add log asterisk, log star.
Yep.
Yep.
And then what about if we decide that logo one is actually something we want to keep track of?
We can actually explicitly add this file, so git add, and that will override the git ignore behavior, I believe.
Yes. Are you sure that just a regular git add will do it?
Maybe we can force other things. Like
yes, I think you will need so you need to apply -f if it's explicitly mentioned in the git ignore, because otherwise, if it was the case that if git add always added it regardless of the ignore, when we go git add star, it'll still add everything, which isn't what we want, right?
Yeah.
So
actually never done this thing. Yeah.
Well, it's an interesting thing. I think it's a good point. Is that so a lot of people are lazy and go git add star to add all the files in the current directory, and if git add ignored when you mentioned a file, it would just add everything and completely ignore your git ignore. So that's why if you specifically like absolutely yes, please track this file, git add -f is what we're after. And the last thing I'll mention in this section is all of these settings, and they're stored in plain text files, so git ignore and .git config, and they both apply at a project and a global level. So if you'll see here, I have a .git ignore file here, but if I go to my home directory, I also think I have a git ignore in here. Okay, I don't have a git ignore in here. Sometimes I have a git ignore sometimes I have a git ignore at my home directory, which is the root level, and so for example, like here's just one. In fact, can I show you this example? Let me think. Yeah, this should be fine. Give me a sec. Go away. Go away. Go away. Great. Okay, so I have a ignore. So you can set a git ignore global, and so for me, globally for every project, I ignore projectile files, VS Code, ClangD, and Emacs local variables. And so you can specify this, and if it can come in real handy if there's just a thing that you don't want to have to change your project's git ignore, but you want to ignore files yourself, you can do it globally. And that's pretty interesting, I think. So I think right now we should take a quick 10-minute break. If anyone has any questions or specifics about history, logs, git ignoring, committing, please stick around and ask us questions. Otherwise, we'll grab a quick 10-minute break.
Just to add some things about git ignore global. So actually, that's very interesting. So I have quite a vast experience of using Git because I'm a software developer and I have a lot of experience with that thing, but I always add this things in each project for git ignore, and actually that's very useful insight. So I'll definitely look into it. So thank you.
You're welcome. The specific reason as to why I came to that is I was working on a professional code base, and Emacs is a thing that only I do in my organization. So I can't just say commit to our projects, git ignore, say, please ignore this specific file just for me. I can't really do that. So I have to take control myself and say, no, just for me, I want to ignore this thing. And so maybe if you have specific Vim configurations like editor configs or folds, and you don't want to have to ignore them in every single project you use, you can add it globally, which is quite handy. And if this is all going over the top of your head, guys, don't worry. This is a bit of, hacking for hacking's sake, but just making you aware of it. Stop share. And to be specific, you will have to have the line you will have to, I'm just going to paste in line, you will have to have the line you will need that. So to further answer the question that you asked Aiden about, does the git ignore go in each directory of the repository? Emily's answered this. You can put it in the parent directory of the repository. However, also you can put it in subdirectories. So I know, if you're aware of the monorepo code pattern where you have a bunch of different projects within one Git repository, you can have a git ignore in every single subfolder to look at project specific configuration settings. So yes, you can put it wherever you want, and Git will ignore it just the same. But typical practice for a single project is to put it in the root directory and refer to things with relative paths, but you don't have to.
All right. Hopefully everyone has made it back. Can I get thumbs up if you're back at your keyboards, ready to get going again? Excellent. Ah, all the thumbs up. Amazing. Yes, excellent. Okay, everyone's here. All right, in that case, I am going to screen share again. So we got a little bit into the weeds before the break with some reverting changes, reverting mistakes, things like that. But we're going to kind of start fresh again. We're going to start with a slightly different topic. So it's really important that everyone follows along from this point, because at this point, we're going to start connecting up your local repository to a repository hosted on GitHub. So I'm going to share my screen. And as always, feel free to shout out if you have any questions. So we're starting with remotes in GitHub. Now, we've so far been focused on tracking changes on your local computer. But the power of GitHub really comes in when you're able to track changes not only that you make on your computer, but maybe that you make on Cetonix as well, or that your supervisor or collaborator makes on their own local machine. So now we're going to connect up this local repo planets to a repo on GitHub, as I said. So the first thing we need to do, and I'm going to get my Zoom controls out of the way, is we're going to go to GitHub. So I want everyone to pull up a browser, go to github.com and log in if you haven't. Can we get thumbs up when you're all logged in and on a page that looks something like this for your own account? We have 1, excellent, 2, 3, 4, 5, 6 that I can count. Excellent. I'll just give everyone another minute or so. Okay, so now on GitHub, we're going to go to repositories and we're going to create a new repository and we're going to call it planets because we want it to be the same name as our local repository to make life easy. Okay, now we're going to make it public because public means that anyone on the web at all can see it. We're going to talk a little bit about the difference between public and private in a minute, but for this exercise, we want it to be a public repo because we're going to share them with each other a little bit later on. So we've got public. We also have the option to add a README. We're not going to here because we don't need it. If we were starting this repo from github.com without anything on our local machine, we could also make a git ignore template here, but we already have one of those, so we're not going to worry about that. And we're not going to worry about a license. So now we're going to create our repository, and you should have a page that looks something like this. So this is the stage where we're going to start actually making the connection between our local computer and GitHub. So we've got some instructions here, which are all very helpful. And essentially what we've done at this point by creating this repository on GitHub, we've done a make dir for planets on GitHub, and we've changed into it and we've done git init on GitHub servers somewhere in the cloud. So now what we need to do is connect this up. We're going to use SSH. There is also the option to use HTTPS, but both of them require a little bit of setup, and SSH is something that you're probably going to find useful. Well, you've already seen it once yesterday in connecting to Pawsey systems. And in general, it's just, we think it's probably going to be more useful for your project. So we're going to run with SSH here. So now we need to all go back to our local computers, our local repositories. And I'm just going to change the size of this so I can see it. Okay, and we need to set up SSH on our local computer to connect to GitHub. So the first thing we're going to do is we're going to copy and paste this address up here that we have on our GitHub page. And we're going to, in our planets directory, I'm in planets, we're going to do git remote add origin. And then we're just going to paste in the address of our remote repo on GitHub. And that should run successfully. If it doesn't shout out, now we have a remote repo and we can check that by using the command git remote with the v flag. And you should get this. So our origin is now linked to, in my case, my GitHub is called eKerosene. So it's linked to my remote repo in eKerosene called planets.git. Hopefully everyone should have that. I'm assuming silence is a good thing. Okay, so now we need to set up an authentication for GitHub. And basically that means we need to tell GitHub that it's us connecting, that it can trust us and the updates that we're pushing. And from our side too, we want to know that we're connecting to GitHub and not some, I don't know, dodgy malicious server that is trying to steal all of our precious, precious code. So the way we're going to do that is via SSH. So I want you to all enter this command. We're going to go ls, we're going to use AL flags, and we're going to check if we already have an SSH folder in our home directory. So we can see that I do. Some of you might already, that's okay. If you don't, we're going to go through the process of setting one up. So I'm just going to remove these because I shouldn't need them. If I do, that's a problem for me later on. Those. Okay, so now if I go ls al, and if you've already got this set up, that's fine. You don't have to go through this again, but we want to go through it for everyone who doesn't have it set up. So now you might get this, or you might get an error when you do the ls command saying that directories does not exist. That's also fine because we're going to set it up now. So now we're going to go back to the tutorial, and we've given you the command to set up an SSH key pair, which is about halfway down the page here. So we're going to copy and paste this, but we're going to change the address here to be your own email address that is linked to your GitHub account. I'm going to go SSH, pgen, and the T flag just tells us that we're using this particular type of encoding. So you can use different kinds of encoding, but this is the one we want here. And C for comments. So my account is linked to my Gmail. And you should get a prompt for where to save your public-private key pair. It should be in your home directory under the hidden.ssh file. That's totally fine. I'm just going to hit enter. And we need to give it a passphrase. Make it something that you're going to remember. You'll be asked to enter it again. And then you'll be given this random art image, which basically just means that your key pair has been generated successfully. So if anyone doesn't have that, shout out now and we can troubleshoot. Comments. Oh, Aiden, yeah, okay. So I just removed the directory because I already had public and private SSH keys linked to my GitHub, which is no use for you guys because that doesn't show you how to set it up. So I just got rid of them. So if we look in that same directory now, if I go ls, la, my home directory, SSH, we will see that those, whoops, I used the wrong flag, that's okay. We'll see that those files that I deleted before are back now. And these files just contain the SSH keys that will allow me to talk to GitHub via the command line.
So Emily, when it says enter a file to which to save the key, would I save it in the planets?
No.
Folder?
Well, you can. I don't think it really matters. David might have a better answer for you. I would just save it in your home directory.
Okay.
Easy location.
What are we saving?
The SSH key pair.
So it should just always save it in .ssh in the home directory. There's no reason to. So the reason why we have it in the .ssh directory is if you look at the permissions that are on the SSH directory, it's only read write for the user. So no one else can look at it. So I think it's 666 is the permission, whatever. And that's because we don't want anyone else on this system to ever be able to look at your private key pairs. So always keep it in your home directory because that is your private personal thing. Don't let anyone ever see it, touch it, look at it. That's why we have it there. If you don't have a .ssh directory, then make one. And SSH will complain if you give it the wrong permissions, or I believe SSH keygen makes it for you. The rm.ssh ID was just answering your question, Aiden. Emily already had an SSH key, and the default name is ID ED25519, And so if she was to make another pair, it would give it a different name and mess up the instructions. So we just got rid of it. So rm is the remove command.
So first I'll make a directory SSH in
Yes.
my home folder, and then I can specify the path to that in the command that's asking me for the
It should
file.
give you a default.
Yes.
Or specify the pan. Yeah, it should be enter the file. It should be default, so you shouldn't have to specify a path. Just spam enter. And how do you know if you already have public or private keys? If there are lots of files in your .ssh directory, you will already have some keys. So I'm not gonna. I would show you mine, but I'm not. My .ssh directory has like 6, 7, 8, 9 sets of keys for different machines and organizations. So the default name is IDED25519, but you can have ID RSA. I have one called Pawsey-RSA. I have one specifically for Ubuntu, my Ubuntu VM. I have one for the University Computer Club. I have one for work. I have one for my own servers. So, you can just keep creating these names. And the only reason you change the default name is if you want to call the key something specific. If that answers. So enter a file. So it's going to ask you enter a file for which to save and key. Just press enter. It will make the default one. That is what we want.
So what's the random art image for? Is that anything, or is that just something that...
So you don't have to worry about the random art image.
Okay.
It's kind of... I'm actually not entirely sure why I have it. I'd hazard my best guess is it's just to verify the unique and authenticity. So if it says permission denied, we need to set up that key in GitHub. So we'll fix that up. I'm sorry, I can't pronounce your name. Yao, I think. Yeah. So the ASCII art image is like you to verify the authenticity and the random uniqueness of your key. Because otherwise, how do you know? Plus, it looks cool. I like it. It's funny. So when everyone's finished setting up their SSH key thing, let us know and we can move on.
Yeah, give us a thumbs up or something when it's successful and your LS looks like this. You've got your keys in your home directory. Okay, I see some thumbs up. That's good.
Do you mean the point at which we're about to set the public key? Is that what you mean?
So I just want you, when you do LSLA for your SSH directory, it looks like mine. That's all we need at the moment.
Oh, yeah.
Yep. Cool. Aiden, you generated the key, but you can't see them in your home directory. Okay, can you check under, we want to check under home directory and then in the folder .ssh. And don't forget the A flag so we can see hidden files. Not that that really matters, but it's nice to put it in. Don't have an SSH directory. Okay, Aiden, so if you go CD tilde to go home, and then you go LSLA, whoops, okay, mine's very long, but do you see a .ssh in there at all? Not in the repository directory, in your home directory, which you can get to if you just do, whoops, I always do that. If you do CD tilde, that will take you to your home directory, which in my case is under users. I'll just get back to planets. So we were there. Why would the keys be there? So they're saved there. So as David was saying before, we put the keys in the home directory mainly for security reasons. Your home directory is going to mean that it's harder for other people to look into them and to steal them, because we don't want people stealing your private key. And that's just the default location for them. Because if we put them, I guess if we put them in the directory where we've got our Git repository, then we'd have to be very careful to have them excluded with git ignore, because we definitely don't want those sent up to GitHub. That would be much badness. You have them? Awesome. Okay, so anyone else, if you don't have them, shout out. Otherwise, we're going to move on.
So I can see the .ssh in my home directory. Does that mean it's in there?
Yep, so it should be in there. So if you cd into .ssh and do ls, you should see the ID 25519 files.
Okay.
Okay, so now we want to go back to our planets directory. So for me, that was on the desktop. So cd back into that, however you get there. And then we want to try SSHing. So we're going to do SSHT, and we're going to try SSH to git@github.com. And we're going to get permission denied public key, which is what Yayu was getting before. And this is because we have generated our public keys and our private key pair, but we haven't yet given one of them to GitHub. So GitHub has no idea who we are trying to connect. We need to give it a key so it can identify our machine when we ping it. So what we're going to do now is we want to, what's the best way to do this? Okay, so we're going to cat, remember cat is how you view the contents of files. So we're going to cat in our home directory in the .ssh folder, ID ed 25519.pub. Make sure you do .pub because that's the public key. That's the one that's okay to share. The one that doesn't have .pub on the end is private, and that is the one you absolutely do not want to share with anyone. So I'm definitely not going to cat that on a recorded Zoom call. Okay, so you should get something like that looks like this. It should begin with SSH ed 25519. Then you get this ridiculously long string, and at the end you're going to get the email that you put in to generate your public private key pair, and that should be the same email that you use for your GitHub account. Can I just get thumbs up if we're getting this when you cat your public key file?
No, I haven't. It looks like it's trying to look at it like it's a directory. It's saying pub, no such file or directory.
Okay, so Helen, have you got this? Have you got tilde for your home directory and then in .ssh and then ID ed 25519.pub?
Yeah. 25519.pub, yeah.
So if you ls that directory, is it there? If you do ls home, whoops, I'm not typing in the chat. I'll put it in the chat. You do ls home.ssh like that. What do you see? Do you see that .pub file?
Yeah, ID RSA. Oh, no, I can't see.
Okay. So that sounds like that's the default for your SSH keygen is going to be a different encoding system. So we have a little note about this in the tutorial. You can use a different encoding system. That's fine. That just means, so I guess, first of all, what command did you enter to make your key pair? Did you try using this one where you specified the encryption method?
Well, I just followed what was in the notes and it worked, as in I got the directories reading out.
Yeah, so we actually have, we've got two commands in the notes, one for legacy systems and one for newer systems, which is a little bit confusing.
Oh,
So if you can use the newer one, that would be good, just because the encryption is a bit better. So it's a bit more secure.
Oh, so I can do it again then?
Yep, you can absolutely do it again, and it should make the file this time called ed25519.
Okay, I'll try that.
Mhm. Okay, maybe David, do you want to check in with Helen, and I'll keep going with the rest of it?
Sounds good.
Awesome. Okay, so everyone who now has this, when you cat your .pub file, we want to copy everything apart from your email address. So everything from SSH all the way to the end of the long string. Then we're going to go back to GitHub, and we're going to go to your profile on the top right, and we're going to go to settings. And then in left on settings, we're going to go to SSH and GPG keys. And so here you might already have some keys. If you set up SSH keys with GitHub before, you might have nothing. I have a few here. I'll now delete my old ones because they no longer exist. And we're going to press the new SSH key in the top right. We're going to give it a title. So for mine, it's going to be Mac key. I'm going to leave it as an authentication key, and we're just going to paste in that text that we copied from our terminal. And once we've done that, we're going to add the SSH key. Oh, you're going to have to enter your password. Okay, and then you should see that you have a new key. Mine's called Mac key, should have the date that it's added, and it should never have been used yet. We're about to use it. Can I get a thumbs up from people when you've added your keys to GitHub? Or shout out if you have questions. Okay, showing how to get there again. So Aiden, if you're on GitHub, you want to go to your profile, little profile picture thingy in the top right of the screen. Then we're going to go to settings. And then in settings on the left, you're going to go to SSH and GPG keys. And that will pull up that page. And then the other question was, which one do you copy and paste? Okay, we're copy and pasting the .pub file, the contents of the .pub file rather, because that is the public key. So we're going to go cat home directory SSH ID ed25519.pub. And you're going to copy and paste everything except the email that's spit out in your terminal, because we don't need the email. That's just a comment. That's just so you know what it's linked to. Okay, do I have thumbs up? Have we got our keys on GitHub? Public keys? Eric, excellent. Abraham, lovely. Who else? Jordan, Lara, perfect. Jamie, yay. Kevin, Patrick, yay. Heidi, lovely. I'm sorry, I can't see all your names at once, so I'm having to scroll through the chat. I hope I haven't. Brittany, lovely. I'm hoping I haven't missed any thumbs up, but that seems like the majority. More comments. Just add SSH key. Yes. Recommended title of the key. Oh, we've got a wow face from Carl. Okay, what does that mean? Aiden, recommended title of the key. I would call it something that makes sense to you. You could call it local desktop. For me, I called mine Mac key so that I know that it is the key that's associated with my Mac laptop. You could call it, yeah, I would call it something that's related to your machine. No problem. Yeah, you just add SSH keys. Yes, we just want to add an SSH key. I'm hoping the wow face from Carl was like a yay, wow, it worked, and not a wow, that's a problem. Okay, shout out, otherwise I'm going to keep moving on. Okay, so we've added our SSH keys. Now we're going to go back to the terminal and check that we're in our planets directory, which I am. And now we're going to try that SSH command again. So we're going to do SSH with the T flag git@github.com. And now, enter your passphrase that you set. now you should get a message like this. So I'm eKerrison on GitHub. So I get, hi eKerrison, you successfully authenticated. Yay. So that means now GitHub knows who we are when we're trying to connect. Life is good. Can I get thumbs up if we get successfully authenticated? Or wow faces? Either one. Yeah, I see some thumbs. Excellent. Oh, smiley face. Love it, Jamie. Thank you. Oh, a saxophone. Love it. Yay, celebration. Thank you, Eric. Okay, is anyone not getting this? Shout out if you're not getting this. Otherwise, we will continue moving on. Okay, so I'm assuming we've now all successfully authenticated. So now, just to check, in our repository, we want to do git remote v, and you should find that you get some output that looks something like this. So it's identifying a remote origin that's linked to your github.com account. Now we're finally ready to send things up to the cloud. Oh, I have something in chat. What do I have? So yeah, the passphrase should be the one that you set when you created the SSH key. It should have prompted you when you created it. I got a message. Yes, Kevin, good point. I got a message. The authenticity of the host github.com can't be established, but just continued as normal and it seems to work. Yep, that's correct. So yes, you might see that if you've never connected to GitHub before, because I already had, my laptop already recognized that GitHub was like a trusted address. So it didn't prompt me with that. But yes, if you get prompted with that, just hit enter or yes or whatever, that's fine. We know what it is and we want to connect. Good point, Kevin. Thank you for bringing that up. Okay, so now silence is, I'm hoping, a good sign. So we should have, we're connected to our remote repository. Now to actually send all of our data up to the remote repository, we want to use the command git push. So we're pushing all of the data we have out to somewhere. We're going to push it to origin on the main branch and hit enter. And it's going to think for a while. It's going to ask me for my passphrase again. So it's probably a good idea to note down your passphrase somewhere, maybe in a password manager if you have one, because you might find you're using it quite a bit. Okay, and then you should get a message that looks something like this. So we've got counting objects, delta compression, blah, blah, blah. And right at the end, we have new branch main to main. So this is a good sign. This means that things are successful. And we can check that by going back to GitHub Online. And we're going to go, you can just click on your profile name at the top. Oh, we have chat. I got a message. Is it bad practice to use my laptop password as the key passphrase? I guess it depends on how
Short answer, yes. Bad practice. Do not do that. Do not do that. Do not use the same passwords for anything, because if a hacker gets access to one password, that means they can also hack your GitHub, and that's the first thing that they will try.
Yes, good call, Kevin. Time to fix that. Well, yeah, I guess, Aiden, if you've set up a GitHub, a hacker's going to want to try GitHub because you might have some juicy code on there that they want. Okay, fatal could not read from remote repository. All right, so people getting errors. What output do you get when you try git remote v? Do you get something that looks like what I have? Okay, so what have we got? So Alex, yes. Okay, Alex, have you tried the SSH command? Okay. Yeah, Alex, yes, you found it. So you shouldn't have LAD at all. You need to change. You need to change your address that you're setting up as your remote to the one for your GitHub account, not just copy paste from the tutorial, because you don't want Dracula's planets. Okay, and so Alex, I think David might have to correct me here because I'm going off the top of my head. If you need to change your remote repository, you want to use, I believe it's git remote and then set URL if you've already got one set up. And then you should just be able to paste in what you see on your GitHub.
Yep, I think that's if I remember, I have a different way of configuring remote, so I think that's about right. That seems about right.
So Alex, so you used your Git email, okay, but just make sure you're watching my screen. So what you need though is on your GitHub account, you want to go to your repositories, go to planets, and then, okay, mine now looks different because I have already pushed my changes up, but you want to copy, you should see something that looks like SSH, and you want to copy this address. So it's going to have your name in it, your GitHub name, rather than the one on the tutorial. Does that make sense? Did we need to create the repository? Yes, you need to create your own repository on your own GitHub, because otherwise we have nothing to push to. And so you can create a repository if you just go to your GitHub account, repositories, and then you can create a new one up here. There are instructions in the exercises on the web page for that. So I don't want to hold everyone up. Alex, shout out if you're still having problems, put it in the chat, but we are going to keep moving. So everyone should find, okay, so we've done git push origin main. Everyone should have done that. Give me a sad face or something if you haven't, if it hasn't worked. But to confirm that it has worked, want to go to GitHub, go to your planets repository, and you should now see something that looks like this. So it's going to contain all of the files that we have on our local repository, as well as little messages that show us the message from the last commit where that file was edited. So yours is going to look a bit different to mine because I made all this extra stuff, the Jupiters and the Saturns and whatever, but you should at least have Mars and spaceships in there. Can we get a thumbs up if we're seeing stuff on GitHub? Excellent. Excellent, thumbs up, lovely. Okay, so that is basically all there is to it for setting up remotes. What else do we cover in the tutorial? Again, we have a note. I'll go back to this tutorial so we can see it on my screen. Again, in the tutorial, we have a note on what you would have to do if you were running through a proxy. There are some configs you need to change in your global config file, but we shouldn't need to worry about that at the moment. That's just there for your reference later on. We also mentioned the use of password managers. Password managers are an excellent tool. Highly recommend them. Particularly if you are doing as you should and using different passwords for everything. So what else have we got here? Yes, so now we've pushed things to our remote repository, but what if we want to pull things down? If things are up there from other people or from us working on another machine? And the way we do that is with the git pull command. So we do git pull, and again, we want to pull from origin on the main branch. And enter the passphrase again. Now, mine's already up to date. Yours probably should be too. It would be a bit odd if something changed up there, but I guess it could. So you're going to get this message already up to date. But if something had changed on the cloud, you would get a longer message ending up with basically success, hopefully. The other thing we note in the tutorial is you can use the U flag. And this basically ensures that your branch that you're pulling from your remote repository is the main branch. And it means that you can use git pull without specifying origin main, you can just call git pull. So it makes life a bit easier in the long term because we like to be lazy. The less words we have to type, the better. Okay, so we have a little exercise now. We want you to have a look at your remote repository on GitHub, have a look at planets, and we want you to look at the text that says the commits. So I'll give you a minute to look at this little exercise on your own, and then we'll chat about it.
I still need some help trying to link in.
Did you clone the HTTPS or the SSH when you chose to clone your remote repository?
Well, after I put the
when you add the remote.
Yeah, after I put the ID_RSA.pub in, the key was okay, and that's the one I linked into the GitHub. But it's when I'm trying to use the
Could you paste the output of git remote -v in a message to me, please?
okay, yeah.
Emily, are you trying to talk because you're muted?
Okay, lovely. Thank you. Okay, so I have a message in chat. Where do I find XX commits in the code tab? Okay, so Planets repository. It's below the green code button. So mine here says 10 commits. And then you click on that and we should get this. Does anyone want to shout out and tell me what these 3 buttons are?
Is the left one like the whole hash of the commit, and then the second button is like the first 6, 7?
Yes, exactly. Yep. And then what about the third one?
Yeah, browse the repo.
Yep. Yeah, very nice. So these buttons are good if you want to navigate this in kind of a GUI instead of doing it on the command line. Particularly if you want to go back, again, if you've made a mistake like I did earlier and you want to revert to a previous version of a file, this is a really easy way to first check what this commit is going to look like and then copy its name so that you can use checkout or revert. All right, thumbs up if that sounds good. And then we will move on to the next exercise, which, what are we doing? Okay, GitHub timestamps. So if we go back to our planets repository, we can see that our commits are recorded here in a very user-friendly format. Can anyone think why this might be the case? And is this really how they're recorded? Or is this just making life easy for me? What have we got in chat? Collaboration could be a reason. Yes, very good point, Kevin. So yeah, we record these. This makes it really easy for you to tell how long ago recent commits were. But if you hover over it like I am here, you can see that we actually get the full date is what's stored. This is just the way it's displayed. Alex, my shell's not connecting to github.com. Oh dear. Okay, so Alex, what do you get if you try the SSHT command? So if you try SSHT git at github.com. Do you get you've successfully authenticated message? Yes. Okay, so it is connecting. Are you able to, and then I can't, okay, are you in your planets folder? And you need, don't forget, there we go. Okay, that could be what it is. Okay, and then last thing I think we want to cover in this lesson is git push and git commit right at the bottom of this page. So this is the first time we've seen git push. Can anyone tell me how it's different from git commit?
The difference.
Pushes it to the repo.
Sorry, say again.
The push pushes it to the repo.
Yes, exactly. So commit just records the changes on our local machine wherever we're working, and push pushes them up to the remote repo. Excellent. Yes, git commit changes, saves the changes locally. Yes, exactly, Kevin. Perfect. Okay, there's a final little note here. So we didn't add the README or the license file in our repository. If we had done, that would have meant that we had some interesting, well, I guess, what do you guys think would happen without looking at the solution? Do you think we would have been able to just git push everything we have if there were already some other files in our remote repo? This is a bit of a tricky one because we haven't really talked about it, but I want to hear your thoughts.
You get like conflicts if you have the same file name, but otherwise it's fine.
So I like the first part of the answer, Carl. So you're actually going to run into issues because if we create README files in our remote repo, that's already some history in that remote repo. So when we try and push all of our local history to the remote repo, GitHub freaks out because it's going, well, I have two different sets of history here. I don't know how to reconcile them, how to put them together. So basically you have to be a little bit careful about that. So we have in our solution here. So we get this issue where we're refusing to merge. So this is one case where you would use this flag, allow unrelated histories, when you're pulling down. So first, if you create a README in your remote repository, you first need to pull down that README from the remote repository before you can push all your local data back up to it. I've got messages in chat. Pulling Git code does not depend on the license. Yes, good point. Thank you, David. So yeah, so the issue really is this existence of this extra file in the remote repo. So we would need to pull that down first using this allow unrelated histories flag, which basically means you're telling GitHub, I know that these things don't agree in terms of their history. It's okay in this one instance. Once we've done that, we're then allowed to commit and then push all of our changes, including the README, back up to the remote repository. Okay, so Alex, you're in the folder. I think that's good. Ethan, error when pushing. Push declined due to email privacy restrictions. Interesting. Ethan, did you already have a GitHub account set up before this, or were you setting up the first time with me?
No, I had one before.
Okay.
I just hadn't really used it at all.
Yeah, no problem. I suspect that's going to be one of the settings you already had in your GitHub repository. Off the top of my head, I can't say exactly which one. David, have you got any?
Yeah, that's a setting that you've basically your remote repository is being configured to not allow you to push a commit that would reveal your personal email address. So basically, I'm going to send you a GitHub blog post that kind of deals with that. Your solutions are, I'm going to paste a command in chat that will fix it now, but you may want to consider not having that setting, because I don't know why you'd have that setting, but there's reasons, but it is what it is.
Okay, so if anyone has any other issues, shout out. If not, I think we will move on to the next lesson. In this case, we'd see a merge conflict due to unrelated histories. Oh, okay. Yes, so if we create a README file when we create the remote repo, that means the remote repo has some history, right? The history is the creation of the README. And that history is going to be different to the history we have in planets on our local machine where we created Mars and we put in all those facts about Mars. So if we try and just do a git push of our local repository into the remote, GitHub's going to complain because it sees these two different history trees and it can't work out how to make them mesh. So that's why we have to, in that case, when we've made a README file, we've got to first pull that down from the remote repo into our local repository. And that's when we use this flag that we were given in the answers here, allow unrelated histories. And that just allows GitHub to basically ignore the fact that we have two different history branches for our local machine and a remote repository and smush them together. And then we're okay. Does that make sense, Aidan? It says be careful. Be careful when you, okay. It's saying be careful when you use allow unrelated histories. Basically, it's a very powerful flag that can lead you to overwriting an entire history if you're, say, if you have a remote repo and a local repo that look very different and actually have meaningful stuff in them. If you use this allow unrelated histories flag, you can just overwrite the history from one of them. So basically, you should only ever use this when you're setting up a remote repo that has a README in it that's different to your local repo, because then it's okay to overwrite the kind of history that you have with that README because it's not important. Excellent. Okay, yeah, you failed to push to remote. Okay, awesome. Thank you, David. Okay. Do we have any other questions? If not, we will head on through to collaborating. Okay, in that case, actually, now might be a good time to break for lunch because it's going to be, what, 12:30 in Perth?
Yeah, that's about right.
Yes, many requests for lunches. Okay, why don't we take, what do you reckon, David? Half an hour?
Yeah, half an hour break.
Okay, I will see you all back here at 12:50 if you're in Perth, or 3:50 if you're in Sydney, or I'm sorry, I can't do that many time zones in my head, but half an hour from now. See you all soon.
I can't get my thing set up.
All right, Helen, I might pause the recording and then do you want to maybe share your screen?
Yeah.
Not troubleshoot. And then... All right, welcome back those who are catching up online. So now we should all have our remote repositories set up on GitHub. We have synced it up with our local repository. Now we're going to think about what happens when you have more than one person working on a remote repo. So the context of this lesson, I guess there are two reasons where this might happen in your projects. You might have someone else working on your project with you. You might have a supervisor who wants to check out your code, or you could be working on your code on your local machine and on one of the machines at Pawsey. So this is hopefully going to set you up really well to be able to deal with that and not run into issues with conflicting file histories, basically. So I'm going to share my screen again. And we're going to make a start on this next lesson, collaborating in multi-machine workflows. So at this point, we are going to need those logins that we talked about earlier in the session right at the start. So I want you all to go back to the Excel spreadsheet and pick up your username and password again. I'm going to use the one that Chris was using yesterday. And we are going to use these to SSH into Cetonix, and we're going to set up another copy of our remote repository on Cetonix. So this is mimicking a workflow where you have some code that you want to work on to maybe deploy a simulation on Cetonix or Nimbus, but you prefer to work on your local machine just because it's easier. So I'm going to log in as COU040 into Cetonix. I'm going to open up a new tab just to make life easier, and let's make it green so we know that we're going to be in Topaz for this. Sorry, not Topaz, Cetonix. So I'm going to log in as COU. And one of the few times you're ever going to see me share my password, hopefully, on a Zoom call. Okay, so I am now logged into Cetonix. Can we get a thumbs up when people have logged in? Got a few thumbs up, excellent. And as always, shout out if you have any problems. I'm just going to move this a little bit so I can see it. Okay, and the next thing we're going to do is we're going to go to the Scratch directory. So for those in the Unix beginners workshop from yesterday, we're going to use variables. So the $, we're going to go to my Scratch. I can spell. So you'll see now that I'm in Scratch courses and COU040. You should be in the directory corresponding to your username. How do you log into this? Okay, Eric, so we're going to log in the same way that they did in the introductory session yesterday. We're going to do it with SSH. So I'll open up another tab for you. So what you're going to do is you're going to go SSH, and it's going to be your username at cetonix.pawsey.org.au. And your username is going to be the one from the Google spreadsheet. And then it will prompt you for your password, and that should also be the one that's listed in the Google spreadsheet. We should all be logged on to Cetonix. Okay, so now we need to go through the same process that we did for our local computer, setting up a connection to GitHub so that GitHub knows who we are when we're trying to authenticate, and we can connect to our remote repository. So does anyone want to shout out, be brave, what's the first thing that I need to do? We've just been through this on our local machines. It's essentially the same on Cetonics. So what's the first thing I'm going to need to do? And we give you some hints in the worksheet.
Is that like Git in it? Yeah.
Yep. So we're going to make a planets directory. So we need to make planets. We're going to change into planets and git init. Very good. And again, I can't spell git init. Okay, so now I'm getting the warning about I'm using the branch name master. So I want to switch back to main. So we're going to go git checkout the main. So I'm on main to start with. Git status. All looking good on the main branch. No commits yet. Okay, now what do I need to do next if I want to be connecting up to my GitHub account? What's the first thing we did on our local machines? And I know we kind of jumped around a bit, but hopefully this is a good way to consolidate that because we're doing it again.
Set up that SSH key in the same way. So the key gen.
Yes, perfect. So we're going to keygen again. SSH keygen 25519. See, and we're going to use our email that our GitHub account is linked to. I'm going to save it in home and I'm going to give it a new passphrase. I'm going to enter it again. And I have my nice little random art image. Okay, so now we've set up our SSH key. What do we need to do with it? Oh, we have something in chat. Are we going to link this? Aiden, yes. So the whole point of this is we're setting up a repository to link again back to our remote repository planets so that we can transfer files from here onto our local machine. So we are going to use git clone in a minute. Yes, that's exactly one of the steps we're going to use. But first we need to set up the SSH keys so that GitHub recognizes us from Cetonics. Yep, that's a good point. Ada makes a very good point. We actually don't need to do git init at this point because we are just going to pull down from the remote repository. Yeah, good catch. Someone's on the ball and it's not me. Okay, to make life easier, I am just going to remove the git init that I did. Does anyone want to remind me how I do that?
It's rm-r.git.
Yeah, very nice. Okay, so we've set up our SSH key pair. What else do we need to do so that GitHub will recognize us?
Do we need to put the public key on the website?
Yes, exactly. We need to put the public key on the website again. So I'm going to cat my home directory.ssh id.pub. And I'm going to copy this one over across to my GitHub account, just the same again. Now, at this point, again, give it a useful name. I'm going to call mine Pawsey Test because this is a test account and I don't want to keep it forever. Well, yes, it would be very bad to keep it forever, given that these accounts are used for training. Okay, so I've got my Pawsey public key. And now we're going to check that it's set up with SSH key again. Git at github.com. And you should, so yep, we're going to continue connecting. We trust GitHub. Enter our passphrase. And then after all that, we should get, again, you have successfully authenticated to Git. Can we get a thumbs up if we're all successfully authenticating on Cetonics? Couple of thumbs up.
I'm getting a weird error saying command not found, SSHED 25519.
So you're using SSH. Which step are you at?
I'm giving the key. So I've done the cat command, and then I'm onto the part where I'm giving the unique key for my account, but it's saying command not found.
So when you're trying SSHT,
I've done that part.
Mm-hmm.
And then it's saying authenticity of host can't be established. I just say yes.
Mm-hmm.
And then it will say permission denied. And then I've pasted in that unique key, but it's saying command not found.
So permission denied is telling you that your command's already failed. Pasting in your key is not going to do anything.
Okay.
So, what's the SSH command you're running?
SSHT GitHub, git at github.com. And then
Is this on Satonics?
Yes.
And you've
I
added,
think I know what I've done wrong.
yeah,
Okay.
just need to add the new key on GitHub.
Okay, Aiden asks, why are we making another public key? That's because the other public-private key pair is only associated with your local laptop. So every time you want to use you want to clone your repo from a different machine, you need a new public-private key. Because that private key has got to be associated with your user on your laptop. We don't want to share that with anyone. Solution to permission denied. Okay, have you got the public key, sorry, in on GitHub? Have we copy pasted it in here?
Emily. It's
No,
I was just if Jordan's he hasn't responded yet, but about like if you were to do this using like GitHub desktop, does that do it? Does this do all the same stuff like for you? Because that's what I'm used to. Like you point a repository and everything. Does that create these public private key pairs and everything the same way?
I don't think so. I think GitHub Desktop is an OAuth 2 application, so it'll use your browser to authenticate as opposed to SSH. But SSH is just an authentication method. It's not the only one. It's just the one that's the easiest to use from the command line on Pawsey systems, which is why we're showing it to you, because there's no way in hell you're getting GitHub Desktop onto Satonics.
Yeah.
So I think you're just going to have to cop it and deal with the command line for now, because there isn't really another way around it, unless you want to set up an elaborate rsync system.
Thanks.
How do you get to where you are on GitHub? Okay, so if you're in your planets directory, which is where we would have been at the end of the last session, we are going to go to top right, your little profile. We're going to go to settings, and then we're going to go to SSH and GPG keys. Okay, so if everyone's now got that set up, now we can do what I should have done first, what I should have done before instead of git init, we can clone our repository. So we're going to go on GitHub online, we're going to go back to our repository planets. And under this little green button code, we're going to get our little SSH address again, copy that. And we're just going to do git clone and paste in that address. Okay, and now if I ls in my planets directory, whoops, I have planets again. If I ls in here, I have all of the stuff that I have online. Can we get a thumbs up if we can successfully clone? Couple of thumbs up. And in actual fact, you can see, because I've already made a planets directory, I have kind of planets nested inside planets. So ideally, you wouldn't have made the directory like I did to start with. You could have just git cloned straight into your Scratch directory, and you would have planets there for you. Okay, so now we are ready to make some changes on Pawsey. So I'm going to make a new file called Pawsey Planets. And I'm going to add some text to that. Oh, what have we got in chat? Do we follow the same? Yes, same steps to set up. Yep, amazing. Okay. So I've now got my file, git status, and it's not added yet. So I need to add it to the staging area, git status ready to go, git commit with my message, adding Pawsey Planets. All right, so I've done my commit. What do I need to do now to ensure that that commit is recorded on GitHub? What command did we use to take all of the stuff on our local machine and send it off to GitHub?
The push.
Push, yes, excellent. So we're going to do git push origin main. And so now if I go back to the web browser and I refresh my page, which my Zoom controls are hiding from me, I refresh my page, I find that now I've got Pawsey Planets up on my remote repository. What have we got in chat? After doing git add, I get fatal, not a git repository. Okay, Lara, have you done git clone? To clone your remote repository onto Cetonix? Yes. Okay. If you followed me, I was a little bit silly and I made the planets directory. So if you ls and you see that you have another planets directory nested inside it, you need to cd into that because that's the actual git repo. Yeah. Excellent. Yeah. So if you were doing this again and you were not making my mistakes, you would not need to make the planets directory. You could just git clone and it's going to create the planets directory for you. Okay, so now I want everyone to go back and look at their planets directories on their local machine and tell me what you see. Do we have our Pawsey planets there? We can react. Thumbs up for yes, thumbs down for no. Or I don't know, sad face for no, whatever reactions we have. Oh, and remember, if you only have the one terminal window, and if you want to log out of Cetonix, you can just type log out, and then you'll be back in your own machine. Do you have any thoughts either way? Have we got Pawsey planets in our local?
No.
No, yeah. So is that Kyle? Do you want to tell me why not? What do we need to do to get it into our local
We
repo?
need to pull from the repo.
Yes, exactly. We need to pull again. Okay, and then if we ls, we're going to have our Pawsey planets there. Yay. What was the user password for? Okay, Alex, so if you're doing git push origin main, the password again. Oh, are you being asked for a username? Okay, if you're being asked for a username, that means that it's been set up with HTTPS, not SSH. So you should be able to just do git remote set URL and then paste in the SSH. So git remote set URL and your SSH address. But if that doesn't work, we will have to change it in the config file. How did I exit Sotonix? Okay, I have 2 tabs open. I'm cheating, but if I wanted to exit Sotonix, I can just type log out and then I'm back in my local machine.
Emily, I'm still getting the error, the fatal error, even though I don't have anything nested within each other in my planets file.
Okay, so you're in planets. So if you do ls/la, do you have a .git directory in there? I'll log in again.
No, it doesn't. Oh, it doesn't look like it.
Okay, so do you have anything from the remote repo in there, or is it just like an empty folder?
Oh, I've got like a dot and then a dot and then Pawsey planets .text and then planets. And that's all I've got. So there's nothing
Okay.
like that in there.
So did you say you have planets in there?
Yes.
So CD into that planets. I think that's the nested folder.
Okay.
And now if you do ls.
Oh, now it says planets. Okay.
Yeah. So that is my bad. We shouldn't.
Oh, okay. Yeah.
Original planets folder.
Thanks.
No problem. Okay, so yes. So now we should have. So if you, what have we got in chat? There's git pull your current branch, git pull origin, pull some particular branch. So git pull you can use if we use the U flag before to set GitHub up and basically tell it to use the main branch by default. But otherwise you do have to specify git pull origin main to pull from the remote and pull the main branch. So git pull origin, correct me if I'm wrong, Dave, git pull origin is just telling it to pull from the remote repository. And then you've got to specify main as the branch.
Yeah, so technically speaking, every branch in your local repository can have an upstream URL and a local URL for pushing and pulling, or like a remote and local. And so git pull just pulls whatever the current branch's ref spec is in terms of remote. By default, that should, in all of our cases, that will still be origin main, but it could be different. Whereas going git pull origin explicitly says no, pull the origin remote for this branch. So it's just about being more specific, depending on how you have a branch configured. But it doesn't really matter.
So what else have we got? What's the U thing that sets the main as default? Yeah, so Aidan, this was at the end of our last session. We mentioned it briefly. I go back to remotes here. The U flag. It's called the U flag very originally. So you can set that when you do git push, and that just tells you, okay, from now on, we're going to pull from the same place that we just pushed to. So origin main. Helen, what's the problem?
Yeah, I just can't seem to I'm in my planets, Pawsey planets, but haven't managed to establish a connection.
Okay, so you're in the planets directory on Pawsey.
Yeah.
Have you done git clone? Can you see the stuff from your remote repository?
Well, I've tried to follow the commands as per that page, but it hasn't. I don't think it's worked properly. I'm not sure what to do.
Okay, so you've done git clone because that's on the page, right?
Yeah, when I did that one, it was it asked for a passphrase, which I set.
Mm-hmm.
And then it said failed. So
the instructions we have on the page, remember, you're going to have to change the username from there to your GitHub username. Otherwise, because that currently is not.
Yeah, I've done that.
Done
yeah.
that. Okay.
So it's just trying to go from the authentication stage. It hasn't. I don't know what's gone on, but
so when you do SSH with the T flag, git at GitHub, does that work okay or not?
I've done a few things since then, so I'll try that again.
Yeah.
Sorry, everybody.
No, it's all good. It's important that everyone's up to the same stage.
Yeah, permission denied, public key. So.
Okay, so that sounds to me, have you copied across the public key into GitHub from Cetonics, the key we made there?
I don't think it's
so because we generated
a key properly, because I've tried that and it's I don't know, maybe I should just
do you want to maybe, David, do you want to chat with Helen and see if you guys can sort this?
Yeah, well, Helen, how about we off the Zoom call and have a call in the Slack instead, so everyone else can keep going in the Zoom.
Yeah, sure, thanks. Right.
Okay, so where are we up to? So we have local, remote. What else have we got in chat? Got it set up on your training account, Kevin. You've run get checkout and then git pull. There is no tracking information for the current branch. Okay, so Kevin, you've got to do git pull origin main. It's got to be the full thing. I think that's your issue. Oh, actually, also, so you've created a repository on Cetonics, but we actually don't need to do that. We can just basically in the Scratch directory, you can call git clone and then your SSH address to your remote repository, and that will create the planets repo for you on Cetonics. That's definitely the easier way to do it rather than git initting again on Cetonics. Does that make sense? Yep. Okay. How do you undo a git add? Okay, so we talked about this a little bit before. So when you have a git add, but before you've done commit, you'll get this little prompt once you've done the add that shows you how to remove it, and it should either say git checkout, or the other one, what do I get? Whoops. I get git restore. That's the other option. Yes. Revert is when you've already made the commit. That's the big no-no that I did earlier today. Alrighty, and I also don't want test, so I'm going to go git restore. And remove it. Okay, so now we have a remote repository that is on GitHub, and we've connected it up to our local machine and to Cytonics. So this is a really great way to pass particularly code scripts that you've written back and forth between your local machine and Cytonics. It's much, much better than using the data mover nodes to copy them across, because it's keeping track of the history. So you can make changes on either Cytonics or your local machine, and as long as you git pull before you start and you git push when you're finished, it's going to be up to date, and it's going to be one nice long continuous chain of history, which is excellent. Okay, so that is pretty much all we have to cover with remotes. So after this, we're going to move on to collaboration, and let me just check. So at this point, collaborating. Okay, at this point, it's really important. I actually want you to all go in to your GitHub account, and I want you to delete the key that we've just synced up with Pawsey, because these are on training accounts. And there's a chance that these training accounts are going to hang around and be used by other people because the passwords are public. And we really don't want that associated with our GitHub account at all. So we're going to go back into the SSH section of our GitHub on the web page. We're going to look at the SSH keys, and we're going to delete the one that's related to Pawsey. So for me, it's called Pawsey test, the one I added today. I'm going to delete that. I understand, please delete this key. And that means someone logging in from this training account 40 is no longer going to be able to access my GitHub account. GitHub's not going to recognize them as me, which is good. That's what we want. And you can also, if you want to be really sure, which I'm definitely going to do, I'm going to go back into Cytonics where I'm logged on. I'm going to cd into the home directory of this drive. Oh, we've got a question in the chat. Git restore staged file. Yes, you got it, Aiden. So to just make sure everything's deleted, I'm going to go back into the home directory on Cytonics for this test account. I'm going to cd into the .ssh ls, and I'm going to remove the files id, ed25519, both the one without anything on the end and the .pub. And that just means all of these keys are gone now. There's no way for anyone to access my GitHub account from this training account. And GitHub's not going to recognize it. So that's a very important step. So can I get everyone's hands up when they've done that? I want hands up so they're persistent and I can make sure everyone's actually done it. Yeah, but so while everyone is deleting those, it would be exactly the same to set up a connection to GitHub with your own interns accounts, which you should all be getting access to over the next week or so. And you won't need to delete any keys there because you're the only ones that can access those accounts, so that's okay. But because these training accounts do have their passwords public, it's not a good thing to leave SSH keys hanging around. And in fact, in general, it's good coding practice to clean out your SSH keys every so often, particularly if you know you haven't used them in a while. So you can see on my GitHub account, I only have the two at the moment. I've got the one I use for Pawsey and I've got the one I use for my Mac that I created today, because they're the only machines I really need to be accessing my GitHub account on. So I'm not going to leave anything else hanging around. Okay, Ethan, Carl, Luke, can I get a hands up from you guys if you've deleted your keys? Yes, yes. Who else have I not heard from? Patrick, Jordan, you guys good? Yeah. Yeah. Who else have I not seen a hand from? Brittany, I think I saw your thumbs up. Jayu, we good? Abraham? Yutith Khan? Yes, yes. And Daniel? Yes? Yes? Okay. What have we got in chat? Can Pawsey administrators access our intern accounts? No. No one can access your account except you. So that's why in the introductory session yesterday, Abraham, thank you. That's why in the introductory session yesterday, Chris made a really big deal about you should never give your Pawsey account password to anyone, not even anyone on the help desk. You're the only person that can log into that. So if you forget, you can reset it, but no one else is ever going to log into your account as you. They can see the files that you may have created as part of your account, but they will never log in. Yeah, they will never be you when they SSH into Satonics. Okay, awesome. I think we've had all hands up now, so you can put your hands down. That's good. Now we're going to do an exercise where we're simulating the case where you might have two people working on the same project. That could be you and a project partner. It could be you and a supervisor. It could be you and a boss. So now we're going to go back to this intern training spreadsheet, and you'll see that next to all of your names, you have your own number and your partner's number. So now we're going to get you to all pair up, and we're going to get you to make some edits to each other's repositories. So I want you to all find your partner and get in touch with them, either on Slack or in Zoom in a private chat. And I want you to share links to your GitHub repositories. So we've got some details about this in somewhere, collaborating, where have we got it? We've got some details about this on the worksheet. It starts from the little note after GitHub and large data files. Starts from, oh, I'm still there. Okay. Starting from here. Okay, so everyone, we need you to, first of all, find your partner. And then we need you to go onto your GitHub account, and we want you to share access to your repo with your collaborator. So that means you're going to need to share your GitHub usernames with each other first of all. And then once you've shared your GitHub usernames, you're going to need to go to the place we've captured in this screenshot here. So you're going to go back to your GitHub account. You're going to go back to your repo. I can't find my partner on the Zoom call. Okay. Does anyone else have a missing partner? If so, we can pay you guys up with people who are here. Oh, perfect. Look at that. Eric and Patrick, you guys are now partners. Okay, so to add someone to your repo, we're going to go to it on the web. Planets. Then we're going to go to settings. And then we're going to go to collaborators. And at this point, you can add people based on their GitHub usernames. Oh, Aiden, is that a new hand up? Or is that an old hand? Old hand, okay. Do we have anyone else missing a partner? If not, Kevin, you and I can be partners. Ah, perfect. There we go. Another pair. Show how to get to collaborators again. Sure. Okay, so if we're starting from planets, our remote repo, we're going to go to settings on the top right. And then we're going to go to collaborators, which is the second option on the left. And then here you can add people. No problem. Okay, is anyone else missing a partner? If not, Kevin and I will be partners. Last chance. Alrighty, Kevin, you can be my partner. So you already know my name is eCarrison on GitHub. So if you want to add me to your remote repository. Ah, Jordan. Okay. In that case, we might get you to pair up with Kevin. So now we are, instead of collaborating with ourselves, oh, Aiden's with Jordan. Okay. How do we find our partner's GitHub username? You're going to have to ask them. The partner should see it when they're looking at their GitHub. So mine is eCarrison. I've been gone. Okay, yes, Jordan. So partners. So you're partners with Aiden. So now we've done collaborating with ourselves where we share our code on a local machine and on Satonics. Now we're going to see what happens when you share code with two different people at the keyboard. Jordan, before you do that though, I just want to make sure for you may have missed it. We need to go back into Satonics and you need to delete your public and private key pair. And I also want you to delete it off GitHub. That's really important because the training accounts that we're using now are public. Everyone can see the passwords. So we don't want that hanging around on our GitHub account. So to delete it on GitHub, if you can remember, we're going to go to top right, look at your profile picture. We're going to go to settings and SSH and GPG keys. And then you're going to find the key from Satonics here and you're just going to press delete. So can you let me know when you've done that, Jordan, or if you've already done it? Got it. Awesome. And then the other thing I want you to do while you're still logged into Satonics, which I am, yeah. So I want you to go to your home directory. So just CD and then into .ssh. And then I want you to delete the ID ed25519 files as well, because they only exist for GitHub. And again, we don't want them hanging around. And can I just get like a thumbs up when you've done that as well? Alrighty, so, okay, so Kevin has now invited me to his planets repo. Kevin, do you mind so I'm going to keep showing my screen. Do you mind if other people know your GitHub username so I can clone your repo? Awesome, thank you. Okay, so now the next thing that we're going to do is we're going to go back to our local machine. So log out of Satonics if you're still on there. I'm going to close that tab because I don't need it. So now I'm in my local machine and I'm still in my planets directory. Now I don't want to be there because that's my repo. I want to make a different repo for my partner. So I'm going to cd out of there. So now I'm just in my desktop, no longer in a Git directory. So what I'm going to do is I'm going to git clone Kevin's repo into my desktop. So git clone, and it's going to be git. Oh no, can someone not see my screen? Stuck on the Git web page. Interesting. Can other people see my terminal?
Yeah.
Okay. Maybe it's just a bandwidth thing then. I'll put the command in the chat as well, and the command is also on the workshop pages. So git clone git at github.com, and then I'm going to put in my partner's username. Whoops, that's my password from Satonics. And then planets.git. And I'm just going to hit enter. Destination planets. Ah, okay. So the issue is we already have our own directory called planets, and we need to call it something else. So I am going to call mine planets partner. And I'm going to enter my key passphrase. Okay, and now if I ls in my current directory, I have my own planets, and I also have planets partner. We both add each other. Yeah, both add each other because we'll get you to swap around in a minute. We want you to both be able to make changes to your partner's repo. Oh, yes, I'm sorry. That means I should also add Kevin, which I will do now.
Are we just working through this ourselves, or are we like following with you?
You don't have to follow me. All of the instructions are on the workspace, so feel free to work through them. Sorry, Kevin, I'm just leaving you sitting there. I should have added you. Okay, so now hopefully everyone has cloned their partner's repo into their local directory, so they should have a planets and a planets partner. Now we want to make some changes. So does someone want to walk me through the steps? Let's say I want to add a file called, what do we not already have? I want to add a file called moon.txt. What do I need to do so that it's going to end up in my partner's remote repository?
You can go touch moon.
Yep, moon.txt.
And then use nano and whatever you want.
Yeah. Give me a fun fact about the moon. What am I going to say?
It's a rock.
Sure, it is indeed a rock. Okay, and I'm going to save that. Exit. Okay, now what do I need to do?
Then you have to add it to the state.
Git add moon, and I'll check the status.
Yeah. And then commit.
Oh, sorry, yes. Yes, no, you're right. I've just done that in my own repository, which was really silly. So I'm going to go into planets partner. And I'm going to touch moon. Oh no. Oh, I shouldn't try to do this in a hurry. Okay. Nano moon.txt, it's a rock. And we're adding. Sorry, yes, please continue. Was that Carl? Git status.
Yeah, and then you commit.
Yes. And we're going to give it, yep, descriptive message. So I'm going to say add. And then what's our last step? Sorry?
And then push.
Yes, git push origin name. Okay, so now I want you to all check your own repos and see if your partner's changes have appeared there. So you're going to check it on the web first and see if it's appeared there. So here's a test for you, Kevin. Have you been quick enough? Will I find your changes in mine? Oh, it's made of cheese. Aiden, that's a great fact. I should have added that. Missed opportunity. Next time, I'll talk about the moon made of cheese. Oh no, Kevin's getting permission denied from me. That's not good. Maybe I need to change my settings. Let's go and check that. Collaborator, public repository. One has access to this repository.
Emily,
Yes.
so I'm trying to still clone.
Yeah.
I'm getting the error repository not found, fatal, could not read from remote repository.
Okay. That sounds to me like your partner might have a slightly different address for their repository. Maybe it's not called planets. I mean, I would ask your partner to give you that SSH address that we've been copying the whole time. Make sure that that's
Okay.
right.
Okay, cool.
Yeah. We are. Has a pending invite. Okay, Kevin, maybe you need to accept an invite. I don't know. Okay, and Eric, I can't see the cloned partner planet file yet. Okay, Eric, has your partner Git pushed successfully? How do we see the pending invites without literally navigating to the relevant repository? So you should get an email to your email address that tells you you've got a pending invite. I don't really want to share my emails to everyone in the Zoom call, but you should see it there. And you should be able to view it and accept it. Kevin, done. Amazing. Amazing. I have a fun fact from Kevin. Okay, let's see what this is. Okay, what have we added it to? Let's refresh this. In Mars.txt, aha. Mars is named after the Roman god of war. Yes, that is a very good, very fun fact. Very nice, Kevin. Excellent choice. Okay, can I get some sort of reaction, a thumbs up, a smiley face, a haha, if we are able to see the changes on the web that our partner has made? Oh, I got one celebration. Love it. Thank you, Laura. A clap from Kevin. Very nice. I'm glad to hear mine worked. Oh, a tractor. Love it, Jamie. What else have we got? Is anyone having any problems? Aiden, you're trying? Yep, no problem. Shout out if you're having problems. If not, there's one more thing that we should do, and that is put all of these changes in our local repository on our machine. So does anyone want to tell me how I'm going to do that? Could you repeat remote copy procedure? Which procedure exactly are you? Is it the one to copy my partner's repo? Is that the one you mean? Yes. Okay. So to do that, first of all, you need to make sure you're out of your own planets directory. So at the moment, I'm in planets partner. That's fine. So you want to make sure you're in your desktop or wherever it is, one layer up from where your planets are. So in my case, it's the desktop. And then you're going to go git clone here, and you're going to paste in that address that belongs to your partner's repo. So it's going to look something like, where is it? It's going to look something like git@github.com. And then it's going to be their username in here, whatever it is, /planets.git. So that's to clone it. But then you need to clone it into a folder that's not called planets, because we already have our own folder called planets. So then as a second argument to git clone, you're going to have something like planets partner, or some other folder name to clone it into. Does that make sense? Yes, amazing. Okay, so now I'm going to go back, CD back into my own planets directory. And I'm going to, let's do git log. So we can see the last commit was from Cetonics. That was me. So I don't have Kevin's commit in here yet. What do I need to do to get that? Someone shout out.
Cool.
Yes, exactly. Get cool. And then we do git log again. And we see that my head is now being updated by Kevin. Added a fun fact about Mars. Thank you, Kevin. Okay. Can I get thumbs up if we've all done that successfully? Or shout out again if you're having issues. Thumbs up from Ethan. Amazing. Jamie, Kevin. Amazing. I may be missing some hands. I'm having to scroll through people, but I love seeing reactions. That's all right, Aiden. Shout out if you're having issues. Okay, and so that's kind of bringing us to the end of this lesson. There are a couple of more things just to chat about. Why the permission denied when I try to copy my file to my partner? Okay, so yeah, you may have to accept their invitation, which will be sent to the email you use for GitHub. When you try to copy, so do you mean git push is failing? Yes. You can also see the invitation if you view their repo on GitHub. Yes, very good point, Kevin. Yes, you can. Yeah, so yeah, you may need to accept their invitation to be a collaborator and edit it. No worries. Okay, so there are just a couple of things to chat about down here. So in general, your workflow for when you have connected up to a remote repository, is this the right one? Am I looking at the right lesson? I am looking at the right lesson. Excellent. Sorry for all the scrolling. I hope no one gets motion sick from that. So yeah, there are just a couple more things to cover here. So we've had a chance to switch roles and repeat, which is nice. We've all just done it at the same time. So in general, when you're collaborating with other people, there are a couple of steps to remember. Before you start editing anything on your machine, you want to git pull so that you're getting all the latest, all the up-to-date changes and you don't have any conflicting or diverging histories. After you've done that, you make all your changes to the code, you fix all the errors that you found, you add some nice comments, and then you git add them. So you've got your changes staged, ready to go. Then you commit them so that they are recorded on your local repo. And finally, once you're done for the day, you're ready to, I don't know, knock off and go and get dinner. Then you git push origin main to send them all back to the remote repository. And that should be your gold standard of collaborating with a remote repo. Okay, so we've got a little exercise to think about here. So does everyone want to read this and then let me know what you think? How are we going to find out what changes have been made?
On the command line, would you just look at the log, or is there something else you could look at as well?
Yeah, so git log is a great way to go. That's going to tell you who made the last changes. So that's helpful if you've got, like 15 people or 100 people working on a project. In terms of actually looking at the specific changes, the best thing to do is a git diff, because that's going to pick out the specific lines in each file that have been changed between, yes, git log. Yes, git log is also good. Yeah. So yeah, git log is going to tell you who made the changes, and then git diff is going to pull out the specific changes in the lines of the file. And then the other option is, of course, what if we're looking at the web and we want to see what changes have been made? Does anyone remember how we do this? We looked at it briefly before. What do I want to look at? What buttons can I press? Someone throw an option at me. I'm happy to try anything. Oh, we've got things in chat. Commits, yes, amazing. Thank you both. So I'm going to click on the commits and then I can check here. I can see what's going on. Have a look at the history. And this is going to pull up the things that have changed in this particular commit. Sound good? I'm thinking silence is probably a good sign. What else do we need to cover in this lesson? Yeah, I think they're the main things. So the other thing we have down the bottom in this little yellow box, the 6 effective Git commands. So this is good if you have accidentally forgotten to do a Git pull. So you make some changes and then you realize, oops, there might be changes in the remote repository. So git stash is a really useful command for this. This basically tells Git to set aside all of the changes that you've made and allows you to do Git pull and pull down the latest changes from the remote repository. Then you can use git stash apply, and that's going to allow you to merge your changes, but you'll have to, unless they're really simple, like, you know, adding an empty line in a couple of places, you're going to have to do it interactively in the shell. So it will basically run through all of the changes for you, and it will ask you which options you want to keep. After you've done that and you've made everything sit nicely, you can then, as normal, git add the files you've changed, commit them, and push them back to the remote. So that's just something to keep in mind. That's a good way to recover when you've started editing things before git pulling. And I think that's pretty much all we've got for this lesson. So as always, shout out if you have questions. If not, we will proceed on to the next one.
Hello. If well, two ways of doing this, I guess. If you didn't make a separate branch, and say 2 people working on the same file, and they didn't realize they're doing it at the same time, and they go to push, I guess, and the other person's already pushed before them, they're going to run into conflicts, right? So how would you resolve that on the command line?
Yeah, so if you're unfortunate and you're the second person to push and you find that there are conflicts, you're going to have to git pull to pull down all of the changes. And when that happens, Git will identify places where what you've got in your local repo is inconsistent with what it's pulling down. And then you'll have the option to go through and work out which changes you want to keep and which changes you want to discard.
And does that do it in like an editor, or because I know with the desktop app, it opens it up in VS Code?
Yeah. So yeah, really great question. This is actually the kind of thing that we're going to cover in the next section on conflict. So yeah, I think unless there are any other questions, I mean, it's great that you're, going with the flow. This is clearly a natural flow to the lesson. So unless there are any other questions, we might press on to the next one. And I see David has rejoined us. Hello, David.
Hello, I'm back.
Excellent. Aiden also, was it Aiden I was just talking to? I'm sorry, I'm not looking at names. No? Okay, Aiden, what's your question? Can you go over the different ways to review their review their commits quickly? So I guess, so git log is going to, right. So git log is going to run through just all of the commits that have been made so that you can see who made what commits at what time. Then you can use git diff. That's going to show you, so we talked about earlier, you can use git diff head and then -5 for mars.txt. And that's going to show me the difference between what I've got now and 5 commits earlier. Doesn't matter who made that commit. It could have been me, or it could have been, in this case, my partner, Kevin. And that's going to be the way to look at them specifically. And then on the web, we're going to go to looking at the commits here. And then you can pull up info by looking at these basically these buttons here are going to pull up the, if they're basically going to pull up the repository as it was at that stage when that commit was just made, if you want to do it on the web. I think they're the main options I've covered. Does that all make sense, Aiden? Sound good? Yeah, awesome. Okay, well, David, I know you've just jumped back in, but would you like to take over for the next lesson on conflict?
Yep, we're going to go into conflicts now. So I think we're just going to, I understand some of you guys are probably still having errors. There's not too much content left in the workshop in terms of what we need to cover. So I think we're just going to cover the rest of that content, and then we can go back to fixing people's problems once it's all done. So those people who are all good with everything can head off first. So we'll deal with that later. So I'm going to get this up, and I'm going to share. So I'm going to cover this rather quickly because it's pretty self-explanatory. So if two people modify the same line and the same file in two separate commits, it's going to, and those commits come in at different, aren't numbered off one after the other, it's going to cause a conflict. So we have a very simple example here. We add a line to mars.txt, we push it to the origin, then we commit it and try to push to the origin again when we make a change to the same line, but it's a different change. Git doesn't know which one to take. And so this is the key bit. It will look like this. It will say, here's the commit, the state of the file before your most recent commits. This is what it is at the remote, and this is your commit, and then this is the remote commit. And you need to decide which one to keep for that given spot. And so that's basically, you either decide to remove the bottom set of line or you remove the top line. So this, bunch of arrows, the equal sign and the bunch of arrows is all added by Git to your file. You must make sure that you remove all of them before you commit it, properly commit it, and you must properly commit it afterwards when you get a conflict. Most graphical tools will have slightly cleaner methods for dealing with conflicts, but you should be aware of how to do it manually in case you're doing it on the command line in Satonix. We're not going to get you all to create conflicts because that's going to be a long time and difficult, but just know that is possible to happen. I think we're going to skip this stuff. I don't think it's particularly relevant, and same thing here. Just know what to look out for, which is this. I'm going to pass it on to Emily to have a look, to talk us through the open science section now.
Okay, yeah, cool. Thanks, David. So I will just share my screen again. This one's not content based. Well, it is content, but we're not going to need to be using the command line. It'd be a bit nicer on your brains for the end of the day. So, open science. So in general, the opposite of open isn't closed, particularly when it comes to science. The opposite of open is broken. We really want, to do our best science. Really often that means collaborating with other people. It means we want to put our data out there. We want to let other people look at it so that we can get further along in our analysis. So I guess historically, if we look back at, 150 years ago at science, people were probably less open than they are today. It probably just depends on the discipline. I don't really know. I don't know that much about the history of science. But in general, in the recent past, lots of journals have been put behind paywalls. Now, we tend to be very lucky at universities because universities pay the exorbitant fees that allow us to view these journals for free as students. But in general, this is a pretty closed model. It means that other members of the public who can't, who don't go to universities that pay for the licenses just can't access the science. That said, there's change in the winds. There's a growing number of scientists that now make use of open access repositories of various kinds to share everything from the publication of the paper to the code that they use to do the analysis to the data itself. So really the ideal now for an open science workflow would look something like this. So you might store your data in an open access repository, and there are tons and tons of these. Figshare and Zenodo are some of the biggest ones across all of the scientific disciplines. but you'll find that there are also plenty of smaller ones that are very discipline specific. So definitely encourage you to look at those if that's something you're interested in. When you share your data like this, it will be given its own digital object identifier, or DOI. And that just means that it's really easy to reference this data if someone else wants to use it in a paper, say. So we've got our data is open access, and now it's also really good practice to make your code and potentially some of the output open access. And that's where things like GitHub come in. So GitHub is obviously one of the best places to store code. There are other alternatives which are just as good, Bitbucket. And again, it probably depends on your institution and your supervisors which one you end up going with, but they all do basically the same thing. They're all version control. Then a lot of people like to keep their papers in a private repository while they're making the edits to them, but they might want to share it with their collaborators. So if you're working in something like LaTeX, Overleaf is a really great platform to do this. Again, it's often free for students with institutional access, and it means that all of your collaborators can work on at the same time on a paper draft, rather than copy and pasting it into something like Google Docs. Then when the paper is ready, there are things called preprint servers. So Archive is the biggest one of those, and that just allows us to share our papers without any kind of paywall. And that means that when you finally publish your paper in a journal, you can link to all of these open access repositories that are used at various stages. So your work is entirely reproducible, and it can also be used by others to build on your analysis and find new interesting things. So yeah, we have references. We know that open models of work are much more widely cited, and this work that uses open access data tends to be reused a lot more often too, obviously, because you can see the data. So philosophically, I think it's the way of the future. We really want science to be open access, because the more people that can do science, the more things we're going to find in the data, the more interesting insights we're going to have, the more discoveries we're going to make. So that's just something to keep in mind as you're doing your projects. That said, there are a couple of caveats. Obviously, a lot of the data you're going to be working with at the moment might be proprietary. It might be something that your supervisors have collected and they want to keep private for a little while so they have time to work on it. So as much as we love the open access model, don't just go dumping all of your work onto a public repository before talking to your supervisors. It's really important to cover the boundaries with them first and make sure that you're only making things public that the larger research group agrees can be public at the moment. The other thing to note is with the preprint servers, although they are a fantastic resource, once you get to the stage of publishing papers, which I'm sure you'll all get to very, very soon, you actually have to be careful about what stage you upload your papers to archive. When you do that. Some journals are a bit funny about whether you upload a paper before or after it's been submitted to the journal. So again, that's just something you want to be mindful of. So we want it to be as open access as possible, but not at the cost of losing opportunities that you might otherwise have with journals or with collaborators. So the last thing to note here with open science, we've been using our GitHub repositories at the moment to track very small text files, and we talked a bit about ignoring large data files. On the whole, Git isn't designed to cope with really big files. It's mainly meant to be a place to host your code. So if you are interested in sharing larger files through Git, there is an extension. There's the Git large file storage tool, which is worth looking into if that's something you want to do for your projects or even just later on, really. So that's kind of the rundown of open science, why it's important and how we can do it with GitHub. So I guess we'll just press swiftly onwards to attribution. So this is just we'll run through this really quickly. This is just if you want to make your code public, once you've got a polished version that you're happy with, you should give it a license. And that just places certain conditions on who can use it, how and when. So it's important to think about the kind of license that you want, and that will depend on what kind of patent rights you think are important to you, how you want other people to use your code, whether it can be distributed as part of their own work or not, as well as what kind of things you want your code to be used for. So yeah, again, this is the kind of thing, if you're at this stage, always good to check with your supervisors, your collaborators, even your institution as to what kind of things are acceptable for the work you put out. But just know that it is absolutely something you can do. You can license code. You can even make it citable. And this is a really great thing to do, particularly if you're developing a great body of code and you think it's something that could be useful to other people beyond your own specific research group. If you make your code citable, it just means that you're going to get better recognition for the work that you're doing. And of course, that's what we always want for our scientists. So again, just something to keep in mind, particularly as you get towards the end of your projects, and perhaps you start talking with your supervisors about how your project's going to live on beyond these 10 weeks at Pawsey. So that's kind of a swift run through of open science and attribution. I think at this stage, I'm going to pass back to David to deal with VS Code.
Okay, so we're going to go through this pretty quickly because there's not too much to cover. So VS Code is a pretty great tool for programming in general. If you don't have an editor of choice, I'd recommend starting with this one. I won't get you to follow these steps because will have to install VS Code for your platform, but just know that you'll need to open your project with file open folder. You'll need to enable the editor features because some extensions do read files and do fancy things. There is a Git tab here on the side where you can initialize a repository, or if you already have one, it'll show you your files. You can commit by just typing and clicking the commit button. To push, you can push branches, and you can also view the history. So by clicking on the commits, you can also push your branches and sync with remote repositories, and it's quite good. I'm just going to show you a quick demonstration of how I use Git in VS Code. It's not how I program professionally, but I bring it out from time to time when I need to. Let's go. So make that. Yes, GitHub can be integrated with RStudio, and if you want instructions on how to do that, I replaced the RStudio instructions with VS Code, Kevin, so I can send you those if you'd like. Didn't honestly thought no one was still using that piece of software, but I'm clearly wrong. So here is my VS Code, what it looks like normally. In our Simple Planets repository. This is with blank settings and nothing else. I'll show you what my actual setup looks like in a sec. But to open a file, we'd go open folder, and then we'd select what we want to select. You can see here I have pluto.txt. I can add some stuff, save the file. I come over here to the Git tab, and you'll see I have stage changes and not stage changes. So I can click on it, and it shows me the change that I've made. I click the plus button, and it will stage it for me, which is pretty nice. And then I have these stage changes. I'm just adding things, and I can commit. And you'll see the history comes up here in the commit history. And then I could push this branch to GitHub by pressing that, and it'll be all good. You also have an advantage in this in that it says 10 seconds ago, you're adding some things, and it kind of highlights. And if you scroll over it, it tells you all these other nice, cool little details in the Git blame. And you can cycle forward and back between commits with these buttons over here, and it's all very, very, very fancy. Let me just give me a sec to get my old setup going. Oh no, that was close enough. Anyways, there's not too much else to show other than what I've showed before. Actually, I could open up in another repository. Yeah, so let me share screen again. Yeah, I can show cycling through commits. Let me just go to something that actually has relevant commits first. So let's open the version control workshop. Have a look. Yes, we must enable all the editor features. So let's have a look. So we can go to the version control, the supplemental and VS Code things. So here's what Markdown looks like in VS Code. And so this button up the top here says open changes with previous revision. So I click that button and it opens up what the previous revision was. And so I can go to previous change or next change. So I'll go to previous change. You click things. Oh, actually, that's right, because let's go to something that I actually changed a bit. I think changes. I changed this. Yeah, there we go. So you can see here when I click that button this time, you can see what I added and where I added it. And then I can go back another commit, and that's the only commit I made for this file. So it's pretty cool like that. And so you can look at the commit, and then you can look at commit details, file history for various files, whatever branches you want to look at. So I can check them out. So I click this button. You can check out the branches. You can sync things with the remote repository. It's quite cool. I won't cover things any more than that, really. And otherwise, if anyone has any other questions, let me know. That's the VS Code section. And with that, that brings us to the end of the version control workshop. If you still had any issues in relation to working with your partner's remote repository, working with remote repositories, setting up Git, or wanted to learn more about ID integration, stick behind and we can go through that. Otherwise, Emily, anything else to wrap up?
Yeah, no, I think that's great, David. Thank you all for sticking with it. This has been a pretty long session, but hopefully it's useful. And yeah, we're looking forward to seeing you all using Git for your projects. Yes, feel free to take off now. We're done for the day. Good job. You're welcome, guys. See you tomorrow.